All right, let's look at our practice test. So we're told to find the GCF, which just stands for the greatest common factor. Some people refer to this as the GCD or the greatest common divisor. So for problem 1, we're given these 3 monomials. And again, we're just finding the GCF. So what is it? And then later on, we're going to be factoring it out. So we have negative 3x squared y to the 4th power. We have 9xy squared. And then we have 12x cubed y cubed. So if you get a problem like this and you're told to find the GCF and you have these monomials involved, what you want to do is you want to separate the coefficients from the variables and treat them as 2 different problems. And then when you're done, just slap it together. Okay. So in other words, I'm going to work on this negative 3, this 9, and this 12. Just like if I said, what is the GCF of, forget about the fact that's negative, what is the GCF of 3, 9, and 12? So if we take 3 and we take 9 and we take 12, remember, to find the greatest common factor, you want to break these numbers down into the product of prime factors. So you want to find their prime factorization. 3 is a prime number, so you can just write that. 9 is 3 squared, or 3 times 3, and 12 is 4 times 3, and 4 is 2 times 2. So 2 times 2 times 3. Now, what you want to ask yourself is, what is common to everything? Okay, it has to be common to everything. There's a 3 here, there's a 3 here, and there's a 3 here. So I know that when I'm building my list, let's say I put a GCF list here, that 3 would go in there because it's common to everything. Now, if it's common to everything, you want to go with the smallest number of repeats between any of the prime factorizations. So in other words, I have 1 here, I have 2 here, and I have 1 here. The smallest number of repeats is 1. It occurs here, and it occurs here. So that's why I'm only putting 1 of these in when I build the GCF. Now, when you look at this prime factor of 2, it occurs twice here, but it doesn't occur here or here. It's got to be common to everything for it to go in. So the greatest common factor here would be 3. Now, in some situations, you're going to need to factor out the negative of the GCF. When we say greatest common factor, generally we're referring to 3 in this case, but in some situations, your book will expect you to know that if you're factoring something out, you might have to factor out a negative 3. Okay, so just keep that in mind. So let's get rid of this. We don't need this anymore. I'm actually just going to put 3 here. And now let's think about the variable part. So I don't actually need to go through and factor the variables. You just think about the fact that if it's going to be common to everything, first off, the variable would have to be in each monomial. So first off, does it have it? So does everything have an x? Yes, yes, yes. So once it has it, just list it. Then you want to go with the smallest power on any of those monomials. So this one's a 2, this one's a 1, and this one's a 3. So I'm going to put just x to the first power there. Because again, if I was to list this out, this would be x times x, this would be x, and this would be x times x times x. Well, what's common to everything? Everything has at least 1x. Everything doesn't have 2. This one would fail. Everything doesn't have 3. This one would fail, and this one would fail. So you've got to go with the smallest exponent that occurs on that variable. Okay, that's why you're doing it. Now, if you look at y, again, the first question is to ask, is it in every term? Yes, yes, yes. So list it. What's the smallest exponent? 4, 2, 3. So it's going to be a 2. Okay, so my GCF is going to be 3xy squared. All right, let's look at problem 2. So we're going to see 20x to the 4th power y squared z, then negative 15x cubed y squared, and then 30x cubed yz squared. So let's work on the number part first, or the coefficients here. We're going to take 20. And again, I'm going to factor that. It's 5 times 4. And then 4 is 2 times 2. So let me just actually write this as 2 times 2 times 5. And then I'm going to get rid of the negative there and just say this is 15. So that's 5 times 3. So let me put 3 times 5 like this. And then for 30, that's 6 times 5. And 6 is 2 times 3. So let me put 2 times 3 and then times 5. Okay, so what's common to everything? Does everything have a 2? No. Does everything have a 3? No. Does everything have a 5? Yes. There's a 5 there, and there, and there. So my GCF, or my greatest common factor, would be a 5. So let me put, for the number part, or the coefficient of this guy, it's going to be 5. Now, the variable part is quicker. Does everything have an x? Yes, yes, yes. So list it. What's the smallest exponent? 4, 3, 3. So it's going to be a 3. Then, does everything have a y? Yes, yes, yes. Put a y. The exponent is 2, 2, and 1. So just leave y to the first power. Does everything have a z? Yes, no. So stop. Z will not be common to everything. So it's going to occur here and here, so it would be common to those two terms, but again, it won't occur here, so it's not common to this one, so you don't put it in the GCF. So the GCF here would be 5x cubed y. All right, let's look at problem number 3. So we have 165x to the 6th power y squared z cubed, and then we're going to have 231x to the 4th power y squared z squared, and then we'll have 165x cubed y squared and then z. All right, so we only have two different coefficients here. You have 165 here and here. So I'm just going to list that once, and then I'm going to list my 231 here. Now you might be thinking, how are we going to get the prime factorization for these guys? Well, you would look at this first one here. It ends with a 5. So from your divisibility rules from pre-algebra, you know that tells you it's going to be divisible by 5. If you do that on a calculator, 165 divided by 5 would be 33. And then you should know, or if you don't, it's not that big of a deal, 33 divided by 3 would be 11. So I could write this as 3 times 5 times 11. Now, in most cases, if you have another number here, another coefficient, it'll be divisible by at least one of these. It might not be, but it's a good place to try. 231 off the top of my head, I don't know what it's divisible by, but I'm going to check for divisibility by 3. I know it's not divisible by 5 because it ends with a 1. But 2 plus 3 is 5. 5 plus 1 is 6. 6 divided by 3 is 2. So that tells me this number 231 is divisible by 3. So if we do that on a calculator, we get 77. And so I would put 3. 77 is 7 times 11, so times 7 and then times 11. So you could have also checked for divisibility by 11. That is a little bit longer of a process, but you do 2 plus 1, which is 3, and then you subtract away 3, that gives you 0. So yes, this guy would be divisible by 11. And if you have no idea what I'm talking about, you want to look into the divisibility rules for 3, 5, and 11. That's where I got that stuff from. Okay, we're moving on here. So what's common to everything? So it looks like a 3 and an 11. The 5 and the 7 are not common, right? So it's just in the prime factorization of 165 for 5 and just in the prime factorization of 231 for 7. Okay, so that means that my GCF will be the product of these prime factors here that are in common. So 3 times 11 or 33. So let's erase this and just put 33 down here. So right there. And then for the variable part, it's really easy, right? So we have x, y, and z. Everything has an x, everything has a y, and everything has a z. So let's write, I'll do this in a different color, x, y, and z. Now what's the exponent? We're going for the smallest exponent that occurs between these monomials. So in other words, on x, I have 6, 4, and 3. So I want the smallest, which is 3. On y, I have 2, 2, and 2. So it's just going to be a 2. And then on z, it's going to be 3, 2, and then this is implied of 1. So I can just leave the z. So my greatest common factor here would be 33x cubed y squared z. Okay, so now let's get into factoring out the GCF. So for problem number 4, we're going to be looking at 6x cubed y squared plus 8x squared y minus 4xy plus 12y. So the idea here is we're going to find the greatest common factor of these 4 terms, and then we're going to pull it out in front of a set of parentheses, okay? So I'm going to go really slow with you on this first one, and then we'll rip through the rest of them. It's a pretty easy process. So first off, what is the GCF, or the greatest common factor? For the numbers, you have 6, you have 8, you have, forget about the fact it's negative, 4, and then you have 12. So 6 is 3 times 2, or actually, let me put this in order. So it's 2 times 3. 8 is 2 times 2 times 2. 4 is 2 times 2. And 12 is 2 times 2 times 3. Okay, what's common to everything? Well, it looks like it's just going to be 2, right? If I go into 3, it's not common to everything, and not everything has a second factor of 2, so you're just going to go with one single 2. So for the GCF, let me just put a 2. Let me just put a 2. And for the variable part, does everything have an x? No, this does not have an x. Does everything have a y? Yes, 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 yes. So I'm going to put a y there. The smallest exponent is a 1, so it's just going to be 2y. So that's my GCF. So this goes out in front of a set of parentheses. Now, what goes inside the parentheses? Well, essentially, you're thinking about the fact that if you were to use the distributive property, the 2y would multiply by something here that would give me 6x cubed y squared. So to get what goes in this position, I just need to divide. In other words, I would go 6x cubed y squared divided by 2y. And what that would give me is 6 divided by 2 would be 3. And then x cubed would be there. Nothing to cancel there. Y squared over y is y. Again, when you go to distribute, 2 times 3 gives you 6. X cubed will be there. And y times y is y squared. So you're right back to that term. That's all you want to do. If you want to do it a different way, you could also say plus. I could factor the 2y out in front. So let me put the 2y here. And then times, I'm going to put 4x squared. So in other words, I wrote this in a way to where it's crystal clear that if I'm pulling out the 2y, I'm just going to have the 4x squared left. The other way you could do that is you could just visibly divide the 2y here, so that's gone, and you're left with the 4x squared. I mean, lots of different ways you can go about making this mentally work for you, but at the end of the day, you're just taking this term right here, and you're dividing out this term to give you what goes there, okay? So if I take 8x squared y, and I divide out this 2y, well, 8 divided by 2 is 4, x squared comes along for the ride, y divided by y is 1. So you just have 4x squared. So let me erase this and just put the 4x squared. And again, if you go through and distribute 2y times 4x squared, 2 times 4 is 8, and then your variable part would be x squared y. Okay, then minus, so again, I'm just going to do this more quickly now. 4xy divided by 2y, 4 divided by 2 is 2, x would be there, y over y is 1. Then lastly, I'm going to go plus, you would have 12y divided by 2y, well, 12 divided by 2 is 6, and then y divided by y is 1. Now, again, when you do these types of problems, if you want to check to make sure you got the right answer, you can go back through and use your distributive property. Okay, so let's look at the next one. And we'll go a lot quicker on this one. So this is problem number 5. So now we have 16x squared y cubed z plus 32x to the 4th power y cubed minus 48x squared y to the 4th power. So we're going to look at the coefficients here, or the number part. Some of you will immediately notice that the greatest common factor is 16 because you have 16 here, 32 is 16 times 2, and 48 is 16 times 3. So if you see that, you just do it right away. But again, if you want to do this the slower way, 16 is what? It's 2 to the 4th power. So 2 times 2 times 2 times 2. 32 is 2 to the 5th power. So 2 times 2 times 2 times 2 times 2 again. And then 48 is going to be 16, which is 2 to the 4th power. So 2 times 2 times 2 times 2 times 3. Okay, so what's common to everything? Again, it's going to be 16. It's going to be these 4 factors of 2. That's common to everything. If something's repeated, you go with the smallest number of repeats. And so the smallest number of repeats, here you have 4, here you have 5, here you have 4. So the smallest number of repeats is 4. So again, it's going to be 16. Let me erase this and let's put this in here. So the GCF, you're going to have 16. And then for the variable part, you have x, x, and x. So x is going to go in there. The exponent is 2, 4, and 2. So it's going to be a 2. And then you have y, y, and y. So let's put that there. The exponent is 3, 3, and 4. So it's going to be a 3. You only have a z there, so that's not coming in. Okay. So all I'm going to do is take each term here and divide away this GCF here to get what goes inside the parentheses. So in other words, 16x squared y cubed z divided by 16x squared y cubed. And you can just do this mentally. 16 over 16 is 1. And then x squared over x squared is 1. Y cubed over y cubed is 1. So this is just z. Then plus, you can do 32 divided by 16, that's 2. X to the 4th power divided by x squared is x squared. And then y cubed divided by y cubed is 1. Then minus, you're going to have 48 divided by 16, that's 3. X squared over x squared is 1. Y to the 4th power over y cubed is going to be y. So this is 16x squared y cubed times this quantity here. Let me put equals. This quantity z plus 2x squared minus 3y. And again, you can always check this with the distributive property. Now, if you wanted to, and your teacher may or may not require you to do this, you might be asked to rewrite this in terms of standard form. So I'm just going to make a small adjustment. So 16x squared y cubed. So inside the parentheses here, I'm going to put the 2x squared first. And then I'm going to put the minus 3y next. And then finally plus z like this. And that's just a matter of personal preference or your teacher. Just get with them in terms of what they want you to put. All right, let's look at problem number 6. So we have 65x squared y squared z squared minus 260x cubed y cubed z cubed plus 91x to the 4th power, y to the 4th power, z to the 4th power. So what is the GCF in terms of the number part? Let me scroll down a little bit here. So 65 is going to be 5 times 13. 260, I know this ends with a 0, so it's divisible by 10. So it would be 26 times 10. 26 is going to be 13 times 2. 10 is 5 times 2. So let me move this up here. So let me put this as 2 times 2 times 13, or actually times 5. So times 5 times 13 like this. Let's get rid of that. And then for 91, we're going to have 7 times 13. So what's common to everything? Well, looks like just the 13. 13, 13, 13. So that's what I'm looking for the number part, or the coefficient. Let's get rid of this. Let's put equals here. I'll put a 13. For the variable part, everything has an x, y, and a z. So let's put those in. So x, y, and then z. Let me scooch this down so it actually fits. And for my exponent, this is a 2, a 3, and a 4. So on x, it's going to be a 2. For y, I have a 2, a 3, and a 4. So it's going to be a 2. And then for z, it's a 2, a 3, and a 4. So again, this is going to be a 2. Okay, so we already know the deal. Inside, I'm going to divide this by this. So 65 divided by 13 is 5. X squared over x squared is 1. Y squared over y squared is 1. Z squared over z squared is 1. So I just have 5. Then minus 260 divided by 13 would be 20. X cubed over x squared would be x. Y cubed over y squared is y. Z cubed over z squared is z. Then plus, you would have your 91 divided by 13, that's 7. And then everything here is going to have an exponent of 2. Right? If I'm dividing x to the 4th power by x squared, that's x squared, so on and so forth for y to the 4th power and z to the 4th power. So let's put 7x squared, y squared, z squared like this. And again, this is a perfectly acceptable answer in terms of giving this. Your teacher may want you to rearrange things in standard form. They may want you to rewrite this in standard form first and then this. It's really up to your teacher. So I'm just doing this as an extra step in case you're required. So let me put 13x squared, y squared, z squared. And then inside, I'm just going to rearrange things. So I'll put 7x squared, y squared, z squared first. And then minus, I'll go 20x, y, z. And then I'll put plus 5. All right, let's look at problem number 7 now. So we have 68x to the 9th power, y to the 15th power, z, minus 153x cubed, y to the 5th power, plus 357x squared, z squared. Okay, so we're getting into some numbers that we really don't work with that often. 68, I know it's even, so at least I know it's divisible by 2. If I divide it by 2, I get 34. And if I divide that by 2, I get 17. So I know that 68 would be 2 times 2 times 17. Now I know that this is odd and this is odd, so you can figure it about 2 being there. So let me write 153 and 357. So this is where you can really shortcut things. You don't have to go around and guess or use the divisibility rules. You're just going to try to divide each one of these by 17. If one of them fails, then the GCF, at least the number part, is 1. So 153 divided by 17 is 9. So this is actually 3 times 3 times 17. And then if I divide 357 by 17, I get 21. So 21 is 3 times 7. So let me write 3 times 7 and then times this 17. So we can see that the 17 is going to be common to everything. So let's use that as the coefficient. Let's get rid of this. And let's take this and put this, I'll put an equals there. So 17. Oh, forgot my variable part. So then we have x, x, and x. Let's put that in. We have y, y, no y. We have z and no z. So only x is going in for the variable part. And then we have a 9, a 3, and a 2. So x squared there. Okay. Inside the parentheses, again, you're just going to divide things. So 68 divided by 17, we know is 4. So this would be 4. X to the 9th power divided by x squared is x to the 7th power. Y to the 15th power would come along for the ride. And so would z. Okay, then minus. 153 divided by 17 would be 9. And then x cubed over x squared would be x. And then y to the 5th power would come along for the ride. Then plus 357 divided by 17 is 21. And then x squared over x squared is 1. So you would just have your z squared there. All right, let's look at problem number 8. So we have 2 times the quantity x plus y plus 4z times the quantity x plus y. So you might look at this problem and go, what in the world are we doing here? But you have a common binomial factor. So this quantity x plus y is what we can factor out. So let me put equals, and I'm going to put that out in front. So I'm going to put x plus y out in front. And I'm going to put some parentheses here. And what's left? Well, I would just have a 2. And then plus, I would have a 4z. Now, we're not done. And the reason we're not done is because if we look at this guy inside here, we have a common factor of 2. Whenever you factor, you want to make sure you factor completely. Okay, so don't miss anything. Always check for additional factoring. This is 2 and this is 4, which is 2 times 2. So that means I could pull out a 2. So in other words, from here, I could say that I had 2 times the quantity. I could go 1 plus 2z, right? If I multiply 2 times 1, I get 2, and then 2 plus 2z, I'd be back to 4z. And you probably want to reorder that and say that's 2z, and then plus 1 like this, and then times your quantity x plus y. All right, now we're on problem number 9. So we have the quantity 5x minus 6 times the quantity x plus 3. And then minus, we have the quantity 2x minus 1 times the quantity x plus 3. All right, so we have this guy right here and this guy right here. So that's the common binomial factor. So I'm just going to pull that out. So let me put equals. Again, I'm going to pull that out. I have x plus 3, this quantity. And then what's going to be left? You could use brackets here if you want. I'm going to have this quantity 5x minus 6. And then minus, don't forget this minus sign. What's left here? This quantity 2x minus 1. So what you actually want to do on this problem is you want to keep simplifying. You notice that you have basically one polynomial minus another, so you can keep going. So this out here, this is x plus 3, this quantity. Inside of here, let me just keep these brackets. I'm going to have 5x minus 6. This, I'm going to go minus 2x and then plus 1. Again, I'm changing this to plus, I'm changing this to negative 1, and I'm distributing this to each term. So this becomes basically your negative 2x plus 1. Okay, let me actually undo all that. Put this back to there, and let me close this down. So now 5x minus 2x would give me 3x. So let me actually write this down here. Let me go x plus 3, this quantity, times, again, 5x minus 2x would be 3x. And then negative 6 plus 1 would be negative 5, so minus 5. So the final answer here would be the quantity x plus 3 times the quantity 3x minus 5. All right, let's look at problem number 10. This one is pretty tedious. I think some people had some trouble with this one. But this is 5y times the quantity x plus 3 being cubed, plus you have the quantity x plus 3 being squared, minus you have 2 times the quantity x plus 3. So what you see here is that the greatest common factor is x plus 3, this quantity, raised to the first power. Here you have it raised to the first power, here it's squared, and here it's cubed. So I just want to pull out one factor. So let me pull out x plus 3, this quantity. What's going to be left inside? I'm going to have 5y times the quantity x plus 3. Now it would be squared because I pulled out one of them. Then plus, you would have x plus 3. This would be to the first power because I pulled out 1. And then minus 2 because this is going to be gone. This guy divided by this guy would be 1. Okay, let me close this down. So all you really have to do now, inside the brackets, you just want to simplify. Let me put this x plus 3 outside here like this. And inside the brackets, let me change colors here. X plus 3 quantity squared, let me put 5y here first. This would be x squared plus 2 times this guy times this guy. 2 times 3 is 6, so this is 6x. And then plus 3 squared is 9. Make sure to keep this inside of parentheses because 5y needs to multiply by this whole thing. Then plus, you have your x plus 3, and then minus 2. Okay, so let me go ahead and drop that down. Let's come down here. Let me put equals. Is there anything in here that we can combine? Well, let's go ahead and see. I'm going to have my x plus 3 on the outside here. Inside, I'm going to have 5y times x squared. Let's write that as 5x squared y. Then plus, I'm going to have 5y times 6x. Let's put 30xy. Then plus 5y times 9. Let's put 45y. Then you're going to have plus x. And then you're going to have 3 minus 2, which is 1, so plus 1. So basically, this is what you're left with. The quantity x plus 3 times the quantity 5x squared y plus 30xy plus 45y plus x plus 1. Now, you might want to rearrange this. Again, depending on your teacher and the standard form definition they have, generally speaking, this has a degree of 1, and so does this. X comes before y in the alphabet. So it's really up to you how you want to leave your answer, if you want to put it this way, or if you want to swap these two terms around. All right, let's look at our practice test. So we're told to factor each, and for the first problem, we're going to be looking at x cubed plus 5x squared plus 5x plus 25. So what we're going to be doing here is using the factoring by grouping method. The first thing you want to do is check to see if your greatest common factor for these four terms here, if it's not 1, then you want to pull it out. In this case, it is 1, so we're going to skip that. The next thing you always want to do is put this into two groups where two terms are in each group, and you want to try to pull out the GCF from that group and see if you have a common binomial factor. If you do, great, pull it out. If you don't, you probably need to switch the terms. In some cases, you'll have something that's prime, and so when that occurs, it doesn't matter how you rearrange things, you won't be able to factor the guy. So what I want to do here is just make the first two into a group. So I'll say x cubed plus 5x squared. That's the first group. Second group, let's go 5x plus 25. Then go ahead and pull out the GCF from each group. So in this group, if I look at x cubed and 5x squared, it would be x squared. So if I pull that out, inside I would have x plus 5. Then from here, if I pull out the greatest common factor, it's just going to be 5. So that's going to be 5 times the quantity. Inside it'll be x plus 5. So what you see here is that you have a common binomial factor. So this guy and this guy, okay, common binomial factor. So you can pull that out. So I'd have x plus 5 that's pulled out. And what's left inside is the x squared. So the x squared and then plus the 5. Always check to make sure that you don't have any other factoring that you can do. In some cases, you'll catch some additional factoring that you need to do, and you want to factor completely. But that's not our case here, so we're just going to report our answer as the quantity x plus 5 times the quantity x squared plus 5. Okay, let's look at the second problem. So we have this 9x cubed plus 3x squared plus 15x plus 5. My greatest common factor between the 4 terms is 1, so you don't have to do anything there. Just arrange this into 2 groups with 2 terms in each group. And so I'm just going to pick the first 2. So 9x cubed plus 3x squared. Say that's a group. Second 2 will be a group. So this won't always work. As you work more problems, you'll be able to eyeball things and very quickly determine if it's going to work out the way that it's originally listed. If it's not, again, you need to start rearranging things. So from this first group, I can pull out a 3x squared. So I can pull out a 3x squared. Inside, I'm going to have a 3x plus a 1. And then plus from this group, I can pull out a 5. Inside, I would have a 3x plus a 1. So you can see that you have this common binomial factor of 3x plus 1. So you're just going to pull that out in front of some parentheses. So 3x plus 1. And then what's left inside? The 3x squared plus the 5. Always check for additional factoring. You don't have any. So my answer is the quantity 3x plus 1 times the quantity 3x squared plus 5. Okay, let's look at problem number 3. So we have 4x cubed minus 10x squared plus 6x minus 15. What is the GCF? Well, again, it's 1. So let me look at this guy again. From just eyeballing it, I know it'll work with the first 2 and the last 2. So let's go 4x cubed minus 10x squared. And then plus, we'll have this 6x minus 15 like this. And again, from the first group, what can I pull out? Well, I can pull out a 2x squared. So 2x squared. Inside, I'm going to have 2x and then minus, you're going to have your 5. And then plus, from this group right here, I can pull out a 3. So just a 3. And inside, this would be 2x and then minus 5. So again, I have my common binomial factor of 2x minus 5. Again, if this is being pulled outside, you'll have your 2x minus 5 times the quantity 2x squared. That's going to be from here. Then plus your 3. That's going to be from there. So again, check for additional factoring. 2x minus 5, that quantity, times the quantity 2x squared plus 3. Let's look at problem number 4. So we have 5xy minus 3x plus 25y minus 15. So the greatest common factor, again, if you look at these 4 terms, it's going to be 1. So you could skip that. In this case, even though you have 2 variables, you can still just take the first 2 as a group and the last 2 as a group. We don't need to rearrange anything. So 5xy minus 3x. And then plus, you'll have 25y minus 15. So from the first group, I can pull out just x. That's all I can do. So I pull out an x. Inside, let me make this more legible. Inside, I would have 5y minus 3. Then plus, over here, I can pull out a 5. Inside, I would have 5y minus 3. Again, I have a common binomial factor of 5y minus 3. So if we pull that out, so 5y minus 3, inside, we would have what? You'd have x, and then plus, you'd have a 5. So again, I always check for additional factoring just to make sure I didn't miss anything. We have the quantity 5y minus 3 times the quantity x plus 5 as our answer. All right, let's look at problem number 5. So we're going to have 60xy minus 96x minus 90y plus 144. So what's the GCF here? Well, it's going to be 6. So I can pull that out to start. Again, if you miss this and you don't pull it out, when you get to your final step, you'll have a common factor of 6 that needs to come out. And if you miss that, your teacher may mark it wrong on your test. So that's why I always say check for additional factoring. You always want to make that last check and see, is there anything else I can pull out? That way, if you missed it here, you can catch it in the end and still get the right answer. But I'm going to go ahead and pull that out now. So we'll have 10xy minus, this would be 16x minus 15y. And then plus, we'll have 24. Okay, so inside now, I think we could speed this up a little bit. From the first group, I'm just going to pull out, if you have 10 and 16, I could pull out a 2. And then I could pull out an x. So I would have what? I would have 5y, and then minus, you would have your 16 divided by 2 is 8. x over x is 1. So 5y minus 8, that quantity. All right, then for the next part, I've got to match the sign. So I want the first one to be positive and the second one to be negative. So I can do that by pulling out the negative of the GCF. So this is where you want to change things. So instead of pulling out the 3, I'm going to pull out a negative 3. So you can put plus negative 3 or just minus 3. That's what pretty much everyone does. And then inside now you would have a 5y. Again, negative 3 times positive 5y would be negative 15y. And then you're going to put a minus here because negative times negative will give you that plus back. And then 3 times 8 would give you 24. So negative 8 is what you want there. So you see you have that common binomial factor of 5y minus 8. So in some cases, you've got to pull out the negative of the GCF. So the GCF there was 3. The negative of that's what you got to pull out so you can make it match. Okay, so here we have 6 times the quantity. I'm going to have this 5y minus 8 times the quantity 2x minus 3. So as I always say, check for additional factoring. Again, if you messed up at the beginning, you didn't pull the GCF out, here's where you can catch it and save your answer. So we get 6 times the quantity 5y minus 8 times the quantity 2x minus 3. All right, let's look at problem number 6. So we have 48xy plus 42x squared plus 40y plus 35x. The GCF here is 1. And the way you can tell really quickly is 35 is 5 times 7. Well, 48 is not divisible by 5 or 7, so you can just stop, okay? So the GCF is 1. So then what I want to do again is just look at the grouping. So in this particular case, I can go with the first two and the last two. That's still going to work. And the next one, we'll see we have to switch it. So from the first two, I could pull out a 6x. And then inside this would be 8y. And then plus, you would have 7x. And then from here, it looks like I can pull out a 5. So let me put that there. Inside, I would have my 8y plus. I would have my 7x. So you have your common binomial factor of 8y plus 7x, like this. Go ahead and pull that out. So you're going to have your 8y plus your 7x, that quantity, times the quantity 6x plus 5. Again, always check for additional factoring, see if you missed anything. We don't see anything, so our quantity 8y plus 7x times our quantity 6x plus 5 is the answer. All right, let's look at problem number 7. So here we will have to actually rearrange terms. We have 60xy minus 112a squared plus 140xa minus 48ay. Okay, so first off, what's the GCF? Everything is even here, so I know it's at least 2. And if I look at all the numbers, again, the final 2 digits of the number, if that forms a number that's divisible by 4, it's divisible by 4. So this guy, 12 is divisible by 4, so is 40, and so is 48. So everything would also be divisible by 4. So let's go ahead and pull that out. That would give me 15xy minus 28a squared plus 35xa, and lastly minus 12ay. Okay, let's close that down. Now, when you look at the grouping, again, normally we just take the first two and then the last two, and that works. In this case, it's not going to. If you look at 15 and you look at 28, well, there's really nothing in common. This is 5 times 3, and this is 7 times 4. And then if you look at the variables, this is xy, and this is a squared. So that doesn't work at all. Here you have xa and you have ay. So you could pull an a out, but look at what you would have left. You would have x for a variable, and then you would have y, and you'd be stuck here with x, y, and a squared. Now, also 35 and 12, if you think about that, this is 5 times 7, and this is 4 times 3. So really, it's just a mess in terms of what you have the ordering now. So what I want to do is I want to make sure I get my variables right. That's what I always check. So I want to see this has an a and this has an a, and this has a y and this has a y. So I want these to be next to each other, because what's going to end up happening is the y is going to factor out, and I'll have an a in one and an x in another. Then if I look at these two being next to each other, well, one of the a's, this is going to be a left, and the a here is going to be gone. So I'd have an a in one, and I'd have just an x in the other. Again, if the y comes out, I have an a in one and an x left in the other. So you're going to rearrange things in that way. Again, this is just from practice. That's how I'm able to do this, from eyeballing it. As soon as you work a lot of problems, you'll be able to do this as well. Okay, so let's go ahead and put these next to each other. I'm going to put 4 times the quantity. I'll say 15xy, and then I'll go minus 12ay, and then let's go plus. I'm going to keep this in the same order, so I'm going to go 35xa like this, and then minus, I'm going to go 28a squared like this. Okay, so let's go ahead and put 4 here. From the first group, I can see that I can pull out a 3y. So let's pull that out. If I pulled out a 3y, what's left? 15 divided by 3 is 5. Then y over y is 1, so I'm just left with the x. then minus. 12 divided by 3 is 4. And then you'd have the a, and y divided by y is 1. So over here, go plus. What can I pull out here? It looks like a 7a. So let's go 7a, then times this quantity inside 35 divided by 7. Let me make this a better. 35 divided by 7 is 5. xa over a is just going to be x. Then minus. 28 divided by 7 is 4. A squared divided by a is a. So you can see that we do have a common binomial factor now of 5x minus 4a. Okay, so that can be pulled out now. So let's put equals here. Scroll down and get some room. So we'll have 4 times the quantity. We'll have 5x minus 4a. And then times the quantity, 3y plus 7a. So again, I always check for additional factoring. We don't see any. So our answer here is 4 times the quantity 5x minus 4a times the quantity 3y plus 7a. All right, let's look at problem number 8. So we have 64x squared y plus 80x squared m plus 128x cubed plus 40xmy. So what is the GCF? Well, notice that everything has an x here. So you can pull out one of those. You put equals. I'm going to put that out in front. And then if I think about it, 64, 80, 128, 40, everything's divisible by 8. So let me pull that out as well. So inside here, I would have 8xy. And then plus, I'm going to have 10xm. And then plus, I'm going to have 16x squared. And then plus, I'll have 5my. Okay, so I pulled out an 8x from each term. Okay, so let's think about the variables. Again, if you're trying to get the grouping right, if I go with the first two, let's think about the fact that x is going to get pulled out, and you'd have y plus m. Well, over here, I have x squared and I have my. So that's not going to work, right? Because I would have x squared plus my. I'm just thinking about the variable part. So that will not work. So I want to arrange this in such a way to where I have an x plus m. So it looks like these two and these two. So if we do this, we'll have 8x times, I'll put my 8xy plus my 5my like this. Let's get rid of that. Then plus, I'll go ahead and say 16x squared, then plus 10xm like this. Close that down. Okay, let's come down here a little bit and see what we got inside. So I'm going to put this over here. So 8x times the quantity. From the first group, I can pull out a y. Okay, so I'll pull out a y, and I'll have 8x plus 5m. From the second group, I can pull out a 2x, and so I'll have 8x plus 5m. So I have achieved my common binomial factor of this 8x plus 5m. So let's pull that out. We'll have the 8x out in front, and then inside, what we're going to have is 8x plus 5m. And then times, we're going to have this y plus 2x. So again, always check for additional factoring. We don't have any. So we'll have 8x times the quantity 8x plus 5m times the quantity y plus 2x. Okay, let's look at problem number 9. So we have 196xy minus 48n squared minus 56xn plus 168ny. All right, so the GCF here would be 4. Everything's divisible by 2. And then also it would be divisible by 4. If you look at 68, 56, 48, and 96, those are all also divisible by 4. And so let's go ahead and pull that out. 196 divided by 4 is 49, so this would be 49xy. Then minus 48 divided by 4 is 12, so 12n squared. Then minus 56 divided by 4 is 14, so 14xn. Then plus 168 divided by 4 is 42, so 42ny. So let's bring this down here. Let's see if it works in order. I don't think it does. So this one, you would have for variables x, y, and then n squared. Let me make that more clear. I think that's probably not legible. And I don't know why I have problems with n, so let me try to make this as cleanly as I can. So n squared, okay. And this one would be, we have xn and ny. The n could come out, you'd have x and y. So x plus y here, and then over here you'd have xy minus n. That would not work at all. So we need to switch the order here. So let's go ahead and say, if we group these two together, you could pull out an n, and so you'd have n plus y. And then if you group these two together, then you could pull out an x, and you'd have y minus n. So it looks like that's what we want. We may have to play with the signs. Haven't really looked at it yet. But let's see what we get. So we have 4 times the quantity. Again, I'm going to put 49xy, and then plus we'll go 42ny. And then we're going to go minus 12n. Let me make that n better. Having trouble with that. So n squared minus 14xn. Let's scroll down a little bit and get some room going. So let's put our 4 here. From the first group, I can pull out 7y. So let's pull that out. I forgot my y, so 7y. Inside, you would have 49 divided by 7 is 7. Xy over y is x. Then plus 42ny divided by 7y. 42 divided by 7 is 6. Ny over y is n. Then here, this is where you need to play with the signs because these are both positive. So let me pull out a negative here. So put minus. And I can pull out a 2n. So what I'm going to have here is both of these are going to be positive because I'm pulling out a negative. So this would be 6n and then plus 7x. Now, if you look at this guy and this guy, they're the same. It's just they're not in the right order, right? And remember, when you add things, because of the commutative property, you could change the order. You can change that now, or you can just swap it around. It really doesn't matter. You just want to make sure that you report your answer as the same. So you can take an additional step, or you can just erase this and say this is 7x plus the 6n like this. It's really up to you how you want to show that. But at the end of the day, you're going to pull this common binomial factor out, okay, the 7x plus the 6n. So you would have 4 out in front, then the 7x plus the 6n, that quantity, then times the quantity 7y minus 2n, and you're basically good to go. Check for additional factoring. You don't have any, so you have 4 times the quantity 7x plus 6n times the quantity 7y minus 2n. Let's look at problem number 10. So we have 14y squared xc plus 24y cubed f minus 56y squared xf minus 6y cubed c. So it looks like my GCF here would be 2 for the number part, and then everything has a y squared, so let me pull that out. So 2y squared, so you'd have 7 and then xc, and then plus you would have 12 and then yf, and then minus you would have 28, you would have xf, and then minus you would have 3yc. Okay, let's close that down. So let's see what we can get into here. Again, we're probably going to have to rearrange stuff. So if I look at the first two, you have xc and yf. Nothing really going to happen there. Here you have xf and yc. Nothing going to happen there. So let's get this guy and this guy next to each other. So I could pull out the f and I'd have y and x. And if this guy and this guy was next to each other, I could pull out the c and then I would have x and then y. So I probably have to change the ordering or the signs or something like that, but it looks like that's what I want. Okay, so let's go through and put that we have 2y squared. And again, I'm going to write these two next to each other. So let me go 7, I'll go xc, and then minus 3yc, like this. And then let me put these two next to each other. And I'll go ahead and just switch the order so it comes out correct. So minus 28xf, and then plus 12yf. If you look at it now, you're going to end up with your x and your y. If you pull out the f here, you'll have your x and your y. So everything should work fine. Okay, let's do this, and let's come down here and see what we can do. So from the first group, let me write my 2y squared. From the first group, I can pull out a c. So pull out the c, and you'll have 7, you'll have x, and then minus, you'll have 3y. From the second group, you can pull out a negative 4f. So inside, that's going to give you 7x, and then you're going to have minus, right? Because again, minus times minus, or negative times negative, will give you that positive back. So then I'm going to have minus, we'll have the 3y. So you can see you do have this common binomial factor of 7x minus 3y, okay, in each case. So let's go through here and put equals, and let's go and say we have 2y squared times the quantity. We're going to have this 7x minus 3y. Then times the quantity c minus 4f, like this. So this is our answer. Again, you always want to check for additional factoring. This is a guard against you missing something in the beginning, okay? If you factor out the GCF in the beginning, you don't have to worry about this. But again, a lot of people miss it, so this is a chance to get all your points. So we don't have anything to factor out. We have 2y squared times the quantity 7x minus 3y times the quantity c minus 4f. All right, let's take a look at our practice test. So we want to factor each. And for the first problem, let me scroll down a little bit. we have x squared plus 11x plus 24. So the idea here is that if you have a leading coefficient here of 1, like we have, then when you set up your two binomials, you know you have an x in the first position of each. So that's taken care of for you. The only thing you need to figure out is what goes here and what goes here. And the way you do this is you find two integers whose sum is this middle coefficient here, which is 11, and whose product is this final term here, this constant term 24. So you would just go through your factors of 24, okay? And then when you find two such numbers, then basically you have your answer that you can put here in any order that you'd like. If you can't find two such numbers, then the polynomial is prime. Okay, it can't be factored using rational numbers. Okay, so in this particular case, the factors of 24, you could do 1 and 24, but the sum doesn't work. That would be 25. You could do 2 and 12. 2 plus 12 is 14. That doesn't work. Then you go to 3 and 8. 3 plus 8 is 11, so that works. So you could put plus 3 here and plus 8 here, or you could switch the order. You could put plus 8 there and plus 3 there. It doesn't matter. The order that you multiply does not matter. So our answer here would be that we can factor this into the quantity x plus 3 times the quantity x plus 8. Okay, let's look at problem number 2. So we have x squared plus 6x minus 16. So let me go ahead and set this up first. So I'm going to put an x here and an x here. Now, when signs start changing, that's when you really have to do a little bit more thinking. If I have a negative product here, that can only come from a positive times a negative. So I know one sign is plus and one sign is minus. You can write that in now if you want, or you can leave it till the end. It doesn't really matter. You also know that because the sum is positive, that the absolute value of the positive number, okay, is larger than the absolute value of the negative number. Now, I'm going to start to think about the factors, and I'm going to only think about positives, and we'll work out the signs. That's how I always do it. If you think about 16, it's 1 and 16. There's no way to make that work. Then you have 2 and you have 8. Let's stop. Can I make that work? Yeah. If I had positive 8 and negative 2, or in other words, 8 minus 2, that gives me 6. Or if I had 8 times negative 2, that gives me negative 16. So I want positive 8 and negative 2. Notice how the absolute value of 8 is larger than the absolute value of negative 2. I knew that because this guy right here is positive. So the positive guy has to outweigh the negative guy. Okay, so that's how I knew that. So I end up with x plus 8, this quantity, times x minus 2, this quantity. Okay, so we get problem number 3. Let's scroll down a little bit. So we have x squared minus 3x minus 18. So let's put this here and this here. Put an x here and an x here so we can forget about it. So now I have a negative here and a negative here. So again, I know that I have opposite signs, a plus and a minus, but the negative now is going to have a larger absolute value. Okay, so let's think about factors of 18. I've got 1 and 18. No way to get that to be 3, or negative 3 is what we're looking for. Then 2 and 9, cannot make that work. What about 3 and 6? Yeah, if I had a negative 6 and a positive 3. So if I had a negative 6 and a positive 3, that works. Negative 6 plus 3 is negative 3. And negative 6 times 3 is negative 18. So this is what we're looking for here. We get the quantity x plus 3 times the quantity x minus 6. All right, let's look at problem number 4. So we have x squared plus 18x plus 80. Okay, so again, let me set this up like this and like this. Everything is positive, so let me put the pluses in there. And so for 18 and 80, let's think about this. So 80, you can do 1 and 80, that's not going to work. You can do 2 and 40, that's not going to work. And let me make that a little bit better. So then what's next? It's not divisible by 3. It is divisible by 4. You could do 4 and 20. That's not going to work. What about 5? Yeah, you could do 5 and 16. Not divisible by 6 and not divisible by 7, but it is divisible by 8. You could do 8 and 10, and that works, right? So 8 plus 10 is 18. 8 times 10 is 80. So this is what I'm looking for here. I have my quantity x plus 8 times my quantity x plus 10. Okay, let's look at number 5. So let's look at number 5. We have x squared minus 17x plus 72. So this guy is positive, but this guy is negative. So what does that tell me? Let me put my x in each position. Well, in order to get a positive product, I can either have positive times positive or negative times negative. So I know this has to be negative and negative. And the reason I know that is because a negative plus a negative is a negative. And again, a negative times a negative is a positive. Okay, so I know my signs already. So let's think about 72. It's 1 and 72, that's not going to work. 2 and 36, not going to work. It's 3 and 24, not going to work. What about 18 and 4? That's not going to work. It's not divisible by 5. You'd have 6 and 12. That won't work. Not divisible by 7, but it is divisible by 8, right? So you could do 8 and 9. So let's say we had 8 and 9. 8 plus 9 is 17. 8 times 9 is 72. So if you put the negatives on it, if you did x minus 8 here and x minus 9 here, that would work. Because you'd end up with your negative 9x and your negative 8x. So that will combine to give you the negative 17x, right? Negative 8 plus negative 9 is negative 17. And then if you do your negative 8 times negative 9, that's your positive 72. So this is our answer here. We have the quantity x minus 8 times the quantity x minus 9. Okay, let's look at number 6. So we have 6x squared minus 18x minus 324. You might look at this and say, well, he didn't show us how to do this. This is not till the next section. But in fact, if you just think about a common principle with factoring, you always want to take your GCF or your greatest common factor out first. You have a 6, an 18, and a 324. If you're in this section and they give you a problem where the leading coefficient is not 1, then it means you can pull it out. Okay, it means I can pull out a 6. So 6, and then inside I'd have x squared minus 3x, and then minus, this would be 54 here. Okay, so when we set this up, I'd have 6 out in front, and then I'd set up my parentheses. Let me get rid of that. Put an x here and an x here. So what are my signs going to be? This is negative and this is negative. So now I have one positive and one negative. Okay, so let's think about 54. You have 1 and 54, that won't work. You have 2 and 27. You have 3 and 18, not divisible by 4, not divisible by 5. Now you do have 6 and 9, and 6 and 9 would work. If you make this guy 9 negative and you make 6 positive, because the absolute value of this guy has to be greater than the absolute value of this guy. So if you do 6 minus 9 or 6 plus negative 9, you get your negative 3. And then if you do 6 times negative 9, you get your negative 54. So we have 6 times the quantity x plus 6 times the quantity x minus 9. All right, let's look at another problem. So this is problem number 7. So we have 3x squared plus 9xy minus 54y squared. So now you might be really mad because you don't have a leading coefficient of 1, and now you have this extra variable. But this is really easy to deal with. Again, if they give you something in this section where this is not 1, you can pull it out. Okay, so you have 3 times the quantity x squared plus 3xy and then minus 18y squared. Okay, now notice I wasn't able to pull out a y there, so what are we going to do with that? Well, basically, all you have to do, if you have a second variable here, like squared like this, and it's here, well, let's go ahead and set this up. Let me say I put my 3 out in front, my x here, and my x here. Well, I could put a y here and a y here, and remember, y times y would be y squared. So that's going to give me that y squared that I need there. Then when I do my outer and my inner, it's x times y. So it's going to combine to give me this, what I'm looking for there. So just put the y in the last position of each and forget about it. Okay, pretend like it's not even there. All you need to do is still focus on the 3 and the negative 18. So because this is minus, again, I know I have a plus and a minus here. Okay, and then thinking about factors of 18, it's not 1 and 18, it's not 2 and 9. You could do 3 and 6 here, but I would want to do a positive 6 and a negative 3, right? So basically, again, think about this like this. This would be negative 3xy, and this would be positive 6xy. If you combine those, 6xy minus 3xy would give you your 3xy. So that part takes care of that. Then for the final, you have 6y times negative 3y. We know it's negative. 6 times 3 is 18. Y times y is y squared. So we're basically good to go. Our answer is 3 times the quantity x plus 6y times the quantity x minus 3y. All right, let's look at problem number 8. So we have 5x squared y squared plus 45xy cubed plus 100y to the 4th power. All right, so again, this is where I can just pull out a GCF. In this case, it looks like I can pull out a 5y squared. So 5y squared. So you'll have x squared plus, this is going to be 9, and then you're going to have xy, and then plus, you're going to have 20y squared. So same deal as before. Let me write the 5y squared out in front. I'm going to put an x, I'm going to put a y, I'm going to put an x, I'm going to put a y. Everything's positive, so let me put plus and plus. I just need this and this. That's all I need. It's pretty easy. Again, you're just looking at this guy and this guy. So two integers that multiply together to give me 20 and sum to 9. Well, with 20, immediately comes out 5 and 4, right? 5 plus 4 is 9, and then if you do 5 times 4, that's 20. So let me put a 5 here and a 4 here. If you go on the outer, that's going to be 4xy. The inner would be 5xy. So if you combine those, you get your 9xy. And again, if you do 5y times 4y, that's 20y squared. Okay, so you're basically good to go. So 5y squared times the quantity x plus 5y times the quantity x plus 4y. All right, let's look at problem number 9. So we have 3x squared minus 33xy plus 90y squared. So let's take a look at this guy. Again, I can pull out a 3, and it looks like that's it. So we'd have x squared minus 11xy, and then plus 30y squared. Okay, so what I want to do here, let me set this up as 3 times. I'll put my x, I'll put my y, put my x, and then put my y. Okay, so I know that this is positive and this is negative, so I have to have a minus and a minus. So for 30, I've got 1 and 30, I got 2 and 15, I've got 3 and 10. It's not divisible by 4. It is divisible by 5, 5 and 6. So a negative 5 and a negative 6, that's what I want, right? So a negative 5 and a negative 6. Again, when you think about this, your outer is going to be negative 6xy. Your inner is going to be negative 5xy. So you combine those, you get your negative 11xy. If you multiply them, in the end, negative times negative is positive. 5 times 6 is 30. Y times y is y squared. Okay, so don't let the second variable fool you or trip you up in any way. You just need to list it here, and you're going to be good to go. So our answer here is 3 times the quantity x minus 5y times the quantity x minus 6y. Let's look at problem number 10. So we have 6x squared plus 30xy minus 36y squared. Let me scroll down a little bit and see what we got here. So it looks like I can pull out a 6, nothing else. Inside you'd have x squared plus you'd have 5xy, then minus 6y squared. And then again, I'm just going to put my 6, and then you have x here, y here, x here, y here. So again, if you get this set up with 2 variables, put your x, y, and y. Again, this is only when it works out to where the coefficient here is 1. When it's not, I'm going to show you how to do that over the next 2 lessons. All right, let's look at this. I know this is negative here, so I want a plus and I want a minus. And we just need to work out what's going to go here and here. Well, for 6, if I think about the factors, this is going to go pretty quickly. You have 1 and 6. Can you make that work? Yes, right? Because if I put plus 6 here, and then I put minus 1 here, that works. Because again, 6 minus 1 is going to give you 5. 6 times negative 1 will give you negative 6. So basically, we're good to go. And we have our answer of 6 times the quantity x plus 6y times the quantity x minus y. All right, let's take a look at our practice test. So we want to factor each, and we're going to look at the first problem here. So we have 7x squared minus 58x plus 63. So we no longer have our easy scenario. If we look here, our leading coefficient, or the coefficient for x squared, is now a 7. In the last section, we talked about where the leading coefficient was 1, but now this is the harder case. So in general, you can use reverse FOIL, or what we call trial by error, or you can use the AC method. There's other methods you can use, but those are the ones we're going to focus on. For today, I'm just going to use the AC method. In the next section, we're going to use the reverse FOIL method. So how does the AC method work? Well, I'm just going to tell you in advance, it's quite tedious. The first thing you would do is you would match up this guy to your standard form. So your ax squared plus your bx plus your c. So remember this from your textbook. Essentially, a is the coefficient for x squared. So in this case, that's 7. So a equals 7. Then b is going to be the coefficient for x raised to the first power. In this case, that's negative 58. And then c is your constant term. In this case, that is positive 63. Okay, so we can get rid of this. Now, here comes the first step. You want to multiply a times c. So when you hear AC, it's just the product of a times c. So 7 times 63. So a times c is 7 times 63, which is 441 if you punch that into your calculator. Now, the next step is going to be the most tedious. Now, if this guy right here is positive, then you want to sum these integers that I'm going to give you. If this guy is negative, you want to subtract them. Now, I never worry about this sign here that we're going to talk about in a second. I always work with positives, and I play with the sign at the end, okay? So again, this is positive, so I want to sum. If it was negative, I would want to subtract. So the idea is you're going to find 2 integers such that the product is this positive 441, and the sum is this negative 58. Again, I'm going to look for a sum of positive 58, and I'll play with the signs at the end. I'd need 2 negatives because 2 negatives would sum to a negative, and they would multiply to give me a positive. Now, you'd write out 441, and there's lots of strategies to do this, but essentially, you're just going to have to brute force or use some trial and error to find your 2 integers. For the sake of completeness, I'm going to go through all the possibilities till we get to the ones that we need. In the real world, you probably wouldn't do this. For example, you don't need to check 1 in 441. That's obviously not going to work, right? This would be 442 if you found the sum, so it's not even close to this. But I'm just going to keep going through. This is an odd number, so we can skip things like 2, 4, 6, 8. Any even number, it's not going to work. So you can go to 3, and it would be 3 in 147. But again, that's just too big. 3 plus 147 is 150. So you would move along. It's not going to be divisible by 5. So we're going to go all the way to 7, and it would be 7 in 63. And if you sum those, you're going to get 70. So we're still too far away, too big. And then so I would go to 9, and you would have 9 and 49. And this is where we can stop. 9 plus 49 is going to be 58. Now I want negative 58, so I just need a negative 9 and a negative 49. Again, negative times negative is positive, and negative plus negative is negative. So what I want here would be the two integers. Let me put this here. So negative 9 and negative 49. What I'm going to do is I'm going to now use these two integers to rewrite this middle term. Okay, so this is a bit strange, I think, the first time you see it, but it works out really nicely. So you have 7x squared, and then you can use either one of these. I'm just going to go minus 9x, and then minus 49x, and then plus 63. Let me erase this. So plus 63. Now, did I do anything mathematically illegal? No. Because if I combine like terms here, this negative 9x minus this 49x gives me this negative 58x. We know this is true because we just found two integers, negative 9 and negative 49, that give me this sum right here of negative 58. So once this process is completed, essentially you're just going to use your factoring by grouping. So from this first group, I could pull out an x, and I would have 7x minus 9. From this second group, I could pull out a 7, that's the GCF, but I want to match the signs. I want this one positive and this one negative. So here's where you have to actually pull out the negative of the GCF. Like we talked about earlier, I'd want to pull out a negative 7 here so that I had a 7x or a positive 7x to be more clear, and then minus your 9 here. Again, the signs have to match. That's why I pulled out a negative. So what you see here is you have a common binomial factor, this 7x minus 9 here. And of course, now we can just pull that guy out. So we'll have the quantity 7x minus 9 times the quantity x minus 7. So that's going to be our answer. All right, let's look at the second problem. We'll go a little bit faster on this one. So we have 7x to the fourth power plus 8x cubed minus 12x squared. Whenever you perform factoring, you always want to check to see, can I pull something out at the beginning? If you look at 7 and 8, immediately you know number-wise, no. But if you look at x to the fourth power, x cubed, and x squared, well, hey, everything has an x, and the smallest exponent is a 2. So the GCF, or greatest common factor, is x squared, so I can pull that out. Inside, I would have 7x squared plus 8x, and then minus 12. If you start working on a problem like this and you see something to the fourth power, you immediately know you have to stop and do some additional factoring, right? Because it's not going to work out to where you have a squared guy there, which is generally what you're going to see with these problems. There are exceptions that we'll get to later on, but for right now in this section, the highest exponent is going to be a 2. So let's work on factoring the inside part here. I'm just going to be on the inside. This x squared will always just be outside of a set of parentheses. We don't have to worry about it. We can forget about it at this point. So let's come down here, and I just want to find what is AC. So what is 7, the coefficient for x squared, times negative 12? Well, that's going to give me a negative 84. Now, my b here is going to be 8. Because this is negative and this is positive, I'm going to end up subtracting. And basically, the integer that has the larger absolute value is going to need to be positive, because again, that positive is going to have to outweigh the negative, so I get a positive there. So let's move this over here. I'm going to put negative 84. And again, I'm just going to think about 84. So again, let's go through the possibilities. You'd have 1 and 84, and that wouldn't work. 84 minus 1 would be 83. You have 2 and 42. You can skip through these. You have 3 and 28. You would have 4 and 21. And then when we get to 6 and 14, we can stop. Remember, I said the larger one in terms of absolute value had to be positive. If I do 14 minus 6, or you could say 14 plus a negative 6, that would give me positive 8. And then 14 times a negative 6 would give me the negative 84. So that's exactly what I want. I want 14 and I want negative 6. So again, all I'm doing, let me put this x squared out in front. I'm using these two integers to rewrite this middle term. So I have 7x squared, and then I'll go plus 14x, and then I'll go minus 6x. Again, if I combine like terms, I'm back to the 8x, and then minus 12. Okay, so that's all you have to do. Once you've got this part done, it's just some simple factoring by grouping. So we have the x squared out in front. Inside, from the first group, I can pull out a 7x. That would give me x plus 2 inside this quantity. And then from the second group, it looks like this is negative and this is negative. Well, both of these are positive, so I know I need to pull out a negative. And if I think about 6 and 12, there's a common factor of 6, so I'm going to pull out a negative 6 here. So inside, you'd have x plus 2, okay? Let me close that down. And then you're going to have this common binomial factor of x plus 2. You scroll down and get a little bit of room going here, so we can pull this all out. So at the end of the day, our answer here, we're going to have the x squared out in front, and then we'll have this quantity x plus 2, this common binomial factor, times what's left. You have the 7x, and then you have the minus 6. So x squared times the quantity x plus 2 times the quantity 7x minus 6. All right, let's look at problem number 3. So we have 3x squared plus 19x plus 20. Okay, so let me scroll down just a little bit. Is there anything I can pull out? No. This is 3. And then if you look at 20, 20 is going to be 2 times 2 times 5. So nothing in terms of a GCF that we can pull out. The GCF here is just 1. So the first thing I would do is find A times C. So what is 3 times 20? That's 60. And then what is B? That's 19. So I need two integers that are going to sum to this 19 that multiply to give me 60. Again, if this is positive, you're looking to add the integers. So think about 60. Again, you could throw out things like 1 and 60 right away or 2 and 30. It's just too far away, right? So then you would go to 3 and 20. That is getting closer, but still not there. So the next one would actually work. It would be 4 and 15. 4 plus 15 is 19. So that's exactly what we're looking for. So let's go ahead and say we have 3x squared plus, you can do 4x, or you can put 15x if you want. It doesn't matter the order. It'll end up working out. So plus 15x, and then plus 20. So from the first group, I can just pull out an x, and I'll have my 3x plus 4, this quantity inside. From the second group, I can pull out a 5, and inside I'll have 3x plus 4. So again, you have a common binomial factor, the 3x plus 4, and you're just going to pull that out. So we're going to have this 3x plus 4, this quantity, multiplied by the quantity x plus 5. Okay, let's look at problem number 4. So I have 5x cubed minus 6x squared minus 27x. Can I pull anything out? This has an x, this has an x, this has an x. So yes, I can pull out an x. Number-wise, no. You think about this is 5, that's a prime number, and 6 is 2 times 3. So number-wise, no. But I can pull that x out. So inside I'd have 5x squared. Then I'd have minus 6x, and then minus 27. Okay, so just working on the inside here, what is 5, which is our A, times negative 27, which is our C? Well, that's going to be negative 135. So again, I'm just going to think about positive numbers again, but if you have a negative here, you're going to be subtracting these integers. Okay, if it's a positive, you add them. If it's a negative, you subtract them. So I'm just going to think about the positive factors of 135. And again, you could sort of speed up the process here. You know that this is an odd number, so it's not going to be divisible by 2 or 4 or 6 or anything like that. I would actually start with 5 here and see what I get. 135 divided by 5 is 27. So let me just start with 5 and 27. But that doesn't work. Remember, we're doing subtraction here. You would look at 27 minus 5. That would give you 22. And that's nowhere near what you need. You would want something that was 6. Again, don't worry about the signs right now. We're going to play with those in a moment. So you would skip 6, not divisible by 7, not divisible by 8. It is divisible by 9. It would be 9 and 15, and we can make this work. Again, because this guy is negative, the larger one in terms of absolute value has to be negative. So you would want negative 15 and positive 9. If you do negative 15 plus 9, that's negative 6. Negative 15 times 9 is negative 135. Okay, let's get rid of this. And let's go ahead and use those to write this. So x times, inside you'll have 5x squared. Again, you could put minus 15x here, or you could put plus 9x there, whatever you want to do. So then I'll put plus 9x here, and then minus 27. Okay, so from this part right here, from the first group, it looks like I can pull out, let me scroll down and get a little bit of room here. From the first group, I can pull out a 5x, and that would leave me with x minus 3 inside. From the second group, I can pull out a 9, and that would leave me with x minus 3 inside. So then I have this common binomial factor of x minus 3. So we see that there. Let me write my x out in front. That just stays there. I have this quantity x minus 3. That gets factored out. And then inside the parentheses here, I'd have the 5x, and then plus the 9. So x times the quantity x minus 3 times the quantity 5x plus 9. All right, let's look at problem number 5. So we have 5x to the 4th power plus 28x cubed plus 15x squared. So can I pull anything out? 5 is a prime number. 28 is 7 times 4 basically, or 7 times 2 times 2. So no number-wise. But variable-wise, everything has an x. The smallest exponent is a 2. So let me write x squared here. Inside I'll have 5x squared plus 28x. And then plus, this will be 15 here. Okay, so let me scroll down a little bit and get some room going. And let's think about this now. The a is 5 and the c is 15. So AC here is 75. The sum is 28 that I'm looking for. This is my b. So if I think about 75, I would immediately start with 5 and 15. Now again, because this guy is positive, I want to sum them. So 5 plus 15 is 20. That doesn't quite work. So I would go down to 3 and 25. So if I tried 3 and 25, that would actually work. 3 plus 25 would give me 28. So that's what I'm looking for. So we want 3 and 25. So let's say x squared here times the quantity 5x squared plus 25x plus 3x plus 15. Okay, close that down. So put x squared here. From the first group here, I can pull out a 5x. Inside, I'm going to have x plus 5. From the second group, I can pull out a 3. Inside, I'll have x plus 5. So again, a common binomial factor has been achieved, this x plus 5 here. And so just pull that out. So let me scroll down a little bit. We'll say we have x squared. Don't forget about that. And then you have this quantity x plus 5. And then inside these parentheses here, you have the 5x plus the 3. So x squared times the quantity x plus 5 times the quantity 5x plus 3. Okay, let's look at problem number 6 now. So we have negative 60x squared plus 162x plus 168. So the first thing is, if you get a negative leading coefficient like this here, this negative 60, I always pull out a negative, even if I can't pull anything else out, just to make my life a little bit easier. It's up to you if you do that or not, but that's something I always do. Then if we look at 60, 162, and 168, they're all even numbers, so I know they're divisible by 2. But then also, if you go closer into this, they're also divisible by 3, which means they're divisible by 6. So what I'm going to do is I'm actually going to pull out a negative 6 here. So let's put that out in front. And everything inside would just be divided by this negative 6. So negative 60x squared would be divided by negative 6. That would give me 10x squared. Then 162x would be divided by negative 6. That would give me negative 27x. And then 168 would be divided by negative 6. That would give me negative 28. So close that down. Okay, so now that I have this done, again, what is A, what is C? In this case, A is 10 and C is negative 28. So that would be negative 280. And then we want a sum of negative 27. So again, when I think about this, if this is negative, I'm going to be subtracting. Forget about the negative, just pretend you have 280, but you're going to be subtracting. So obviously you don't want to start with 1 and 280. Okay, that would just be too far away. So I would probably pick something like, let's say 5 to start. You punch up 280 divided by 5 on your calculator, and you would get 5 and 56. So you would just subtract there. 56 minus 5 is going to be 51. That's too far away. I would be thinking about getting positive 27 there. Again, you have to play with the signs, but it doesn't work. It's too far away. So moving up, it's not divisible by 6 because it's not divisible by 3. So I would go to 7 and you would have 7 and 40. But again, 40 minus 7 is 33. So we're not there yet. It is going to be divisible by 8. You could do 8 and 35. And 35 minus 8 is 27. Again, you just have to play with the signs. So what you would want is a negative 35 and a positive 8 so that you get a negative 27. Now, let's get rid of this. We know our integers. You have negative 6 on the outside. You'll have 10x squared. And then again, we had negative 35x, and then plus 8x, and then minus 28. Okay, close that down. So let me put this negative 6 out in front. Inside from the first group, you could pull out a 5x. So I pull out a 5x, and that would leave me with 2x minus 7. Then from the second group, it looks like I can pull out a 4. So let me put plus 4 here. So that would give me 2x minus 7. So again, you have this common binomial factor. So this guy right here, this quantity 2x minus 7, you can pull that out in front of a set of parentheses. Let me put this negative 6, and then times, we'll have this quantity 2x minus 7, and then times, inside the parentheses here, I'll have 5x, and then plus this 4. So we end up with negative 6 times the quantity 2x minus 7 times the quantity 5x plus 4. All right, let's take a look at problem number 7. So we have 24x squared minus 68x plus 48. Can I pull out anything before I start? Yes. 24, 68, and 48, they're all divisible by 4. Let's go ahead and pull that out. Inside, you're going to have 6x squared minus 17x plus 12. All I did was I divided each term here by 4 to get these terms inside the parentheses. Okay, so now 6 times 12 is 72. And again, this is positive, so I'm looking to sum things. And so what are two integers that give me a positive 72 as a product and a negative 17 as a sum? Well, for me, again, I would skip a lot of these smaller numbers. I would start with something like maybe 4 and 18, 4 and 18, but that wouldn't work. That would give me a sum of 22. That's a bit too high. Again, I'm thinking about this in terms of positive 17. And then I would do something like not divisible by 5. You could do 6 and 12, but 6 and 12 is 18 if you add those together, so that doesn't work. Not divisible by 7, but is divisible by 8. You could do 8 and 9, and that's what we need. So 8 plus 9 gives me 17. Again, you just have to play with the signs. We know we want a negative, right? So we want negative 8 and negative 9. Negative 8 plus negative 9 gives me the negative 17. Negative 8 times negative 9 gives me the positive 72. So let's write this. We have 4 times the quantity, 6x squared. I'm going to go minus 8x and then minus 9x. Again, the order doesn't matter how you put that. And then plus 12. Close that down. Let's scroll down here. And then we'll have, let me put equals, 4 times inside the parentheses. From the first group, I can pull out a 2x. So inside, I'll have 3x and then minus 4. From the second group, I can pull out a 3. But you have to be careful here because this guy's positive, this guy's negative. In this case, it's flipped. This is negative, this is positive. So go ahead and pull out a negative 3 to make the signs match. And this would be 3x minus 4 inside. So again, you have your common binomial factor, this 3x minus 4 right here. So let's go ahead and pull that out. We have 4 times the quantity, 3x minus 4. And then times the quantity, you'll have 2x minus 3. So again, 4 times the quantity, 3x minus 4, times the quantity, 2x minus 3. All right, let's look at problem number 8. So we have 20x squared minus 75x plus 45. So everything here, this 20, this 75, and the 45 is divisible by 5. So let's go ahead and pull that out. Inside you'll have 4. So you'll have 4x squared minus 15x and then plus 9. So let's scroll down a little bit and get some room. So the a times the c, so 4 times 9 is 36. And you want a negative 15 as a sum. Again, I'm just going to work with positives. So if you have this as positive, you add the numbers. Okay, forget about the sign. You can make the sign work at the end. If this guy is negative, you subtract. And again, don't worry about the signs. You can play with those and get that right at the end. So for 36, you have 1 and 36, which wouldn't work. You have 2 and 18, that would be 20, that wouldn't work. But when you get to 3 and 12, that's going to work, right? 3 plus 12 is 15. Again, you play with the signs. Negative 3 plus negative 12 gives you this negative 15. Negative 3 times negative 12 gives you that positive 36. So let's write 5 times the quantity 4x squared and then minus 3x. You could also put minus 12x there if you want. It's really up to you. And then minus, I'm going to put 12x and then plus 9. Okay, so let's go ahead and look at the first group. So put the 5 out in front. From this guy, I can pull out an x. And inside you'll have 4x minus 3. And then again, this is positive, this is negative, this is negative, this is positive. So you need to flip this around by pulling out a negative. And what I'm going to do is pull out a negative 3 here. So inside I'll have 4x and then minus 3. Okay, so I have the common binomial factor. All right, so let me go ahead and highlight that. This quantity 4x minus 3. Let me scroll down and get some room. So we can fit all this on the screen. So let's put the 5 out in front. Then we'll have this 4x minus 3. This quantity multiplied by the quantity will have the x and then minus the 3. So 5 times the quantity 4x minus 3 multiplied by the quantity x minus 3. All right, let's look at problem number 9. So we have 50x squared plus 135xy plus 90y squared. So the idea here is that we have two variables involved, but we saw earlier that this really doesn't make our factoring problem any more difficult. We don't even need to consider this. When we do trial and error, all you would do is you would put a y in the second position of each and you would forget about it. We don't actually need to do that here because the factoring by grouping will take care of the second variable. We only still need to worry about the numbers. So finding two integers such that the product is AC and the sum is B, use your regular factoring by grouping. It's no more difficult. But in this scenario, we can actually pull out a common factor of 5. So let me go ahead and do that first. So you would have 10x squared plus, you'll have 27xy, and then plus, we'll have 18y squared. Close that down. So my AC here, 10 times 18 is 180. Everything's positive, but again, if this is positive, you're summing your integers. You could start with 1 and 180, but again, that's just a waste of time in my opinion. So I'd probably start with something like 10 and 18 maybe. 10 plus 18 would give me 28, so I know I'm close. So let me bring this number up and this number down. So it's not divisible by 11, but you could do 12 and 15, and that's exactly what you're looking for. 12 plus 15 would give me 27. 12 times 15 would give me 180. Let's go ahead and use the 12 and the 15. So 5 times, inside you'd have 10x squared, plus, let's go 12xy, and then plus, you're going to go 15xy, and then plus 18y squared. So when you're doing this, don't forget you have two variables there and there. When you combine like terms, you're going to get this 27xy. So again, because there's two variables doesn't make it more difficult. So let's go ahead and look at this. So we have 5 times, inside the parentheses, from the first group I can pull out, you have 10 and you have 12, so you can pull out a 2. Then you have x squared and x, so I can pull out an x. And then inside you would basically have 5x plus you'd have 6y. From the second group, I have 15 and 18, and then I'm going to have y and y squared. So I know I can pull out a y. With the 15 and the 18, I could pull out a 3. So let me put plus 3y. And then inside, I'm going to have 5x plus, this will be 6y. So you see that it worked out. We still have this common binomial factor. In this case, it's 5x plus 6y, so you have the two variables involved. But again, it was no harder. We just found our numbers that we were looking for, and we did our normal procedure. So we have 5 times the quantity. You'll have this 5x plus 6y. Then times the quantity, what's left, you have the 2x, and then plus the 3y. So 5 times the quantity, 5x plus 6y, times the quantity, 2x plus 3y. All right, let's look at problem 10. So we have negative 24x squared plus 138xy minus 189y squared. So again, if this is negative, I always pull that out. And then you would look for something else. So between 24, 138, and 189, forget about the fact it's negative, the greatest common factor would be 3. So I'm just going to pull out a negative 3 here. So this would be positive 8x squared, and then minus 46xy. And this would be plus 63y squared. Okay, so let's close that down. So from here, I multiply 8 times 63, which is 504. So again, this is positive, so I'm going to be summing things. Now, with something this big, I'd probably take the square root of it first, and I would just go down to the nearest integer. So that's, if you punch into your calculator, it's about 22.44. So I know I only need to check to up to 22, but I'm going to take something in the middle. I know it's not divisible by 10, so let me think about if it's divisible by 12, and it is, because it's divisible by 3 and also 4. So I would do 12 times 42. Now let's stop. Am I too high or too low? 12 plus 42, and I should probably put a comma there. That's what I've been doing. So 12 plus 42 would be 54. That's too big. I'm looking for 46. Again, forget about the fact that it's negative. So what I want to do is bring this up and bring this down. Not divisible by 13. You could divide this by 14. You would get 36. If you sum those together, now you're getting 50. So the total's coming down. So let me go up again. You can't do 15 because it's not divisible by 5. 16 is out. 17 is out, but you could do 18. So you'd have 18 and 28, and that would work. 18 plus 28 is 46. Again, forget about the fact that it's negative there. You could just make this negative and this negative, and you will have achieved your two integers. So I want negative 18 and negative 28. So let's use those. So negative 3 goes out in front. You'll have your 8x squared minus 18xy. Don't forget the x and the y. And then minus, you're going to have your 28xy. And then plus 63y squared. Okay, let's come down here. I have negative 3 times, from the first group, I can pull out a 2x. This is 8, this is 18, so pull out a 2. You have x squared and x, pull out an x. Inside, you're going to have 4x, and then minus, this is going to be 9, and then y. From here, again, this is negative and this is positive. If I look at this, this is positive, this is negative. So you've got to pull out a negative there to make the signs work. And it looks like between 28 and 63, you can pull out a 7. And then between x, y, and y squared, you could pull out a y. So inside here, I would have 4x. And then minus, you would have this 9y. Okay, so you see we have this common binomial factor of 4x minus 9y, and that's what we're looking for. Let's pull this down, and let's go through here. Let me change my color. So I have the negative 3 out in front. So I'll have the quantity 4x minus 9y, pulling that out. And then you're going to have times this quantity, you're going to have 2x, and then minus this 7y here. So negative 3 times the quantity 4x minus 9y times the quantity 2x minus 7y. So again, before we leave the video, I just want to make sure you understand, if you don't pull the GCF out before you start, you'll have additional factoring in here. So you always want to check to make sure you don't have additional factoring in case you messed up in the first step. All right, let's take a look at our practice test. So we're told to factor each, and for this practice test, we're going to use reverse FOIL or something called factoring using trial and error. Let's come down here for problem number 1. We're going to take a look at 14x squared plus 96x minus 128. So again, the first thing I want to do when I encounter any factoring problem, I want to pull out the GCF if it's not 1. In this case, you'd notice that 14, 96, and 128, those are all even numbers. So I know at minimum I can pull out a 2. So usually I'll pull that out first and see if there's something else I can get out. But in this case, that's all you can do. So this would be 7x squared. Plus, if I divide 96 by 2, I get 48, so 48x. And then minus 128 divided by 2 would be 64. So now I can just factor this trinomial on the inside. You don't have to worry about the 2. You can just keep copying it. So I'm actually going to set this up into 2 binomials here. And essentially, we have an easier scenario because this guy right here, this leading coefficient, or the coefficient for x squared, is a prime number. 7 can only come from 1 times 7. So this really knocks down the possibilities. I can go ahead and say this is 7x and this is x. Of course, you could reverse that. It doesn't really matter. But at the end of the day, I need to check stuff, and I need my outer and my inner to work out to this positive 48x. Now, there's a couple of things that will speed up the process. Remember, if you have a negative at the end, that comes from this guy times this guy. So that means something's got to be positive and something's got to be negative. If this guy was positive, then that means you either have 2 negatives or 2 positives. So we can use this to our advantage. If we have a negative product here in the end, then basically what you want to do is you want to try out these factors of this guy, and you want to subtract. Don't worry about the signs. I'm just going to work with positive numbers. You want to subtract. If the sign is wrong, but the absolute value is correct, you can flip your signs around. It doesn't matter. Okay, so you just want to work with positive numbers. It just makes it quicker. If this guy is positive, then you're going to be adding what you get. Okay, and we'll see examples of this as we move forward. So because this is negative, I'm going to be doing some subtraction. Now, what am I going to subtract exactly? Let's scroll down and get a little bit of room. Well, I'm going to look for factors of 64. And so that's 1 and 64. That's 2 and 32. That's going to be, let's see, 4 and 16. And then lastly, you'd have 8 and 8. Remember, you only have to check up to the square root of the number. Square root of 64 is 8, so we can stop there. So now when we think about this, you're going to basically go through and do something like this with trial and error. So you could start with 1 and 64 here. And of course, you'd have to flip the order. So you're going to check the outer and the inner, and you're going to subtract. So you would do 7 times 64, and obviously that's too big, so you can just stop without even doing it, because you're going to be subtracting away this guy right here, which is 1. If you did that on a calculator, you'd basically have 448. So forget about the x for a second. You'd have 448x, but forget about that. You'd have 448. This guy would be 1. If you subtracted, you'd have 447, so that's not possible. You could flip around the order. So you could say this is 64 and this is 1, but that's still not going to work. The outer would be 7 and the inner would be 64, and I'm trying to get to 48. So again, that doesn't work. So I can just get rid of this as a possibility, and you just move down the line. Now, once you get good at this, you can eliminate stuff like that right away. It's just too big. So then I could look at 2 and 32. So you could put a 2 here and a 32 here. But again, 7 times 32 is 224. That's too big because the other guy is just 2. Right? So that's not going to work. Now you can flip the order around, and you could put 32 here, and you could put 2 here. But remember, you're subtracting in this case. So the outer here is 14, and the inner is 32. And if you subtract there, you're going to get 18. So this is not a possibility either. So you get rid of that. So next you go to 4 and 16. If you put 16 here and 4 here, 7 times 16 is 112. Again, you're going to be subtracting away 4. That's just too big. Right? You'd end up with 108. If you flip this around, and you put a 4 here and a 16 here, again, this is going to be 28, and this is going to be 16. 28 minus 16 is 12, and again, I'm looking for 48. So let's get rid of this as a possibility. So the only thing that's left is 8 and 8. And for this, it doesn't matter how you put it. So I'm going to put an 8 here and an 8 here. Obviously, the signs are going to matter, but it's the same number, so I just need to check it once. So my outer would be 56, and then my inner would be 8. Now, I'm going to do a subtraction because, again, this guy's negative. So if I do 56 minus 8, I do get 48. Okay, so I want to work with 8 and 8, but now I need to play with the signs. Now, I know this sum here is positive, so that means the larger in terms of absolute value has to be positive. So the 7x times the 8. I want a positive here, and I want a negative here. Again, you can stop and FOIL. In fact, I think it's a good idea to do this the first time, just to show that we got the right answer. So you have your 2 out in front, and then 7x times x is 7x squared. And then your 7x times 8 would be your plus 56x. Negative 8 times x is minus 8x. And then lastly, negative 8 times positive 8 would be negative 64. So inside here, you can combine like terms. The 56x minus the 8x gives us our 48x. So you go plus 48x like this. And of course, you could multiply everything by 2 here to get back to your original polynomial, this 14x squared plus 96x minus 128. Okay, let's look at the second problem. We can speed up the pace a little bit. So we have 15x squared plus 69x plus 72. And essentially everything is positive here. So that means I want to add, okay? If this guy is positive, I want to add. If it's negative, I want to subtract, okay, in terms of setting up your integers. So let's put equals here. Is there anything I can pull out? Well, I know that 15 is 5 times 3, and this guy, those are not divisible by 5. But 6 plus 9 is 15. 15 is divisible by 3, so will 69 be. And 7 plus 2 is 9. 9 is divisible by 3, so 72 will be as well. So I know I can pull out a 3, and inside I would have a 5x squared plus 69 divided by 3 would be 23, so 23x. And then plus 72 divided by 3 would be 24. Again, because this 5 here is a prime number, it's going to make our life a lot easier. I'll put the 3 out in front. Let me put the 5 here. And, well, actually, I need to put a 5x here and then an x here. Again, because 5 can only come from 5 times 1. Now, in terms of this and this, again, you're going to look at this 24, and you're going to find the factors, and then you're just going to use trial and error. So, again, 24 is going to be 1 and 24. It's going to be 2 and 12. And then 3 and 8, and lastly 4 and 6. Okay, so remember, we're doing addition here. If you start with something like 1 and 24, if you put a 1 here and a 24 here, that's obviously too big, right? You're looking for 23, so that's too big. If you flipped it around and put a 24 here and a 1 here, immediately you can tell that's too big as well. So you can get rid of this right away. Now you have 2 and 12. Would that work? If I had a 2 here and a 12 here, the outer would be 10, and the inner would be 12, so that's not enough, right? Because if this is 10 and this is 12, 10 plus 12 is 22, I need 23. If I flip that around and put a 12 here and a 2 here, that's too big, right? 5 times 12 is obviously 60, it's just too big, so get rid of this. So then you have 3 and you have 8. So I put a 3 here and an 8 here. The outside here would be 40, that's too big. So you can flip this around, and you could put a 3 here and an 8 here. The outside here would be 15. The inside here would be 8. And 15 plus 8 is 23. So we found what we need. So let me go ahead and get rid of this. I'll put a plus here and a plus here. So we want 3 times the quantity 5x plus 8 times the quantity x plus 3. And again, you can always stop and check this using FOIL. All right, let's look at problem number 3. So we have 35x squared minus 45x minus 50. All right, let me scroll down a little bit so we can fit this on here. So if you notice, everything ends in a 5 or a 0. So that tells me everything is divisible by 5. So let me go ahead and pull that out first. So we would have 7x squared minus, this would be 9x, and then minus 10. So inside here, again, I'm lucky because this is a prime number. So let's go ahead and say that we have 5 times, I'll have 7x here, and I'll go ahead and put x here. And then, again, what goes here and here? Well, I'm going to look at this guy right here. It's negative. So if it's negative, that means one sign's positive, one sign's negative. So when I go through with these integers, I want to subtract. Now, what I'm going to do for 10, I have 1 and 10, and I have 2 and 5. So again, I'm just going to play with things. If I put a 10 here and a 1 here, that's obviously too big, right? Because I'd end up with 70 minus 1, which is 69, and I'm looking for just basically 9 here. It's going to end up being negative 9, but I'm looking for 9 here at this point. So that doesn't work. If I flip this around and put a 10 here and a 1 here, well, let's go ahead and do that. Let's put a 10 here and a 1 here. You can eyeball that and see that's not going to work. You'd have 7 and you'd have 10. So 10 minus 7 would give you 3. So that doesn't work either. So you can get rid of this one right away. So next you have 2 and 5. So we have 5 here and 2 here. The outer's too big, right? It's 35 and this is 2. Subtract those, you get 33. So that's not going to work. If I put a 5 here and a 2 here, does that work? 7 times 2 is 14. Let me write that down. 5 times 1 is 5. So 14 minus 5 gives me 9. So again, in terms of absolute value, this is a 9 and this is a 9. Right? Don't worry about the signs for right now. You found the correct number in terms of absolute value. Now you just need to play with the signs. I want this guy to be negative. So I want the larger guy, which in this case is 14, I want that to be negative and I want this to be positive. So in other words, I want this 7x to multiply by a negative 2. That's going to give me a negative 14x, right, when I do my outer. And then I want this to multiply by a positive. So in other words, positive 5 times x, this would give me plus 5x. And again, this gives me the correct middle term of this negative 9x. So my factorization here is going to be 5 times the quantity 7x plus 5 times the quantity x minus 2. Let's take a look at problem number 4. So we have 5x squared plus 13x minus 6. So let me scroll down a little bit. And in this particular case, I don't have anything I can factor out. The GCF is going to be 1. So I'm just going to start by making some parentheses here. And essentially, again, we have 5 as the leading coefficient. So I know that this is 5x and this is x. So we'll see some cases where it's not a prime number. When you get that, it's a little bit more difficult. So this guy right here is negative. So again, that tells me I'm going to be doing some subtraction. And for 6, if I think about the factors, I have 1 and 6, and I have 2 and 3. So we can pretty much fly through this. If you want to put a 1 here and a 6 here, this is too big, right? The outer would be 30. The inner would be 1. If you subtract there, you're going to get 29, and I'm looking for 13. So that does not work. You could put a 6 here and a 1 here. That gives you 5 and 6, but obviously that's not going to work. 6 minus 5 will give you 1. So that is not going to work. You can get rid of this. So next, I'm going to have 2 and 3. So I could put 2 here and 3 here. The outer would be 15. The inner would be 2. 15 minus 2 would give me 13, so it looks like that's what I'm looking for. Again, you just have to work out the signs. This guy right here, the 5x times the 3, needs to be bigger, right, because this is a plus. So I'm going to put a plus here so I can get a 15x here. And I'm going to put a minus here so I can get a negative 2x here. 15x minus 2x would give me that plus 13x that I'm looking for. So this guy factors into 5x minus 2, this quantity, multiplied by the quantity x plus 3. All right, let's look at problem number 5. So we have 3x squared plus 5x minus 15. Let me scroll down a little bit. Now, can I pull anything out? In other words, is the GCF not 1? Well, immediately you see 3 is a prime number and so is 5. So our greatest common factor here, or the GCF, is 1. So nothing I can pull out. So let me go ahead and set up some parentheses here. And of course, we have another easy case scenario because our leading coefficient, or the coefficient for x squared, is a 3. And of course, 3 is a prime number. So I can just put 3x here and x here. And I just need to work out what goes here and what goes here. Now, because this, again, is a minus, or you can think about it as subtraction, you're going to end up with a positive and a negative. Okay, so a plus and a minus. So that means when you work with these integers, you want to do subtraction. So let's just think about 15. And what are the factors of 15? Well, you have 1 and 15, and you have 3 and 5. Now, let's stop for a minute. Can I put 15 here and 1 here? Is this a valid possibility? No. We talked about this in a lesson, but you might have forgotten. If this trinomial that you're trying to factor does not have a common factor other than 1, when you look at these binomials that you're setting up, you're not going to have a common factor other than 1 as well. So in other words, here you have 3x and you have 15. 15 is 3 times 5. So this binomial here on the left has a common factor of 3. That is not possible because there's not a common factor of 3 in the trinomial I'm trying to factor. So this can be excluded as a possibility. And in fact, using that rule there is going to speed up your work quite a bit. So I'm going to put a 15 here and a 1 here. This is a valid possibility. It's not going to work, but it is valid. So we can have 3 multiplied by 15, and 3 times 15 is 45. And then you'd have basically 1 there. You do your subtraction. 45 minus 1 is going to be 44. So this is out, right? 44 is obviously not 5. So the other possibility is to work with 3 and 5. Can I put a 3 here and a 5 here? No, because there's a common factor of 3, so that is not possible. I can, however, put a 3 here and a 5 here. The outer, 3 times 3 is going to be 9. The inner is going to be 5. If you subtract there, 9 minus 5 is 4, but I'm looking for 5. So I can cross this out. Now I'm out of integers to play with, so what does that mean? It means that my polynomial is prime. You cannot factor this using integers. So let me get rid of this, and we'll say that this is a prime polynomial. Some textbooks will call this irreducible. All right, let's look at problem number 6. So we have 30x squared plus 65x plus 30. And you can see that this ends with a 0, ends with a 5, and ends with a 0. So if a number ends with a 0 or a 5, it's divisible by 5. So that means I could pull out a 5 from everything. This would be 6x squared plus 13x plus this would be 6. Now I'm trying to factor this guy out right here. This trinomial that I'm working on factoring does not have a common factor other than 1. So let's go ahead and put this over here. And I'm going to put this 5 out in front. And I'm going to do this like this. Now, because 6 is not a prime number, it could either be 1 times 6 or 2 times 3, or obviously you could do negatives if you wanted to. Well, what happens is I now have more things to check. I'm going to have to put a second set here. So you could do 6x and x, and then you could do 2x and 3x like this. So it has to be one of those two. And again, as this number gets bigger and bigger, it becomes harder and harder to check all the possibilities. So that's where you probably want to get into the AC method. Okay, so let's come down a little bit. This guy is positive, so I'm going to be adding things. And I'm going to be checking the factors of 6. So with 6, it's 1 and 6, or it's 2 and 3. Now, if I put a 1 here and a 6 here, this is possible, right? So again, if I do the outer, that would be 36, and the inner would be 1. So that would give me a sum of 37. So I can get rid of this right away from this first scenario. And actually, I probably should put 2 of these. But actually, you're going to be able to remove that from the second scenario, and I'll talk about why in a second. You can't flip this around. You can't put a 6 here and a 1 here, because this guy right here, this trinomial, inside the parentheses that we're trying to factor, again, the GCF is 1, so you can't have a common factor of 6 in this binomial. It wouldn't be possible. So you can get rid of that. Now, you can't use 1 and 6 here, because if I put a 6 here and a 1 here, I've got a common factor of 3. And if I flip that around and I put a 1 here and a 6 here, I've got a common factor of 2. So 1 and 6 can be eliminated immediately. 2 and 3 can also be eliminated from this guy immediately, because if you put a 2 here and a 3 here, you have a common factor of 2. If you put a 3 here and a 2 here, you have a common factor of 3. So you can get rid of this altogether. You don't need it. It's not possible. Let's put this up here. And now let's think about 2 and 3. So with 2 and 3, I cannot put a 2 here and a 3 here because you have a common factor of 2. So the only possibility is to put a 3 here and a 2 here, and all the signs would have to be plus. Does this work? Your outer would be 4x. Your inner would be 9x. 4x plus 9x is 13x. So yes, this is our correct factorization. We're going to want 5 times the quantity 2x plus 3 times the quantity 3x plus 2. All right, let's look at problem number 7. So we have negative 27x squared minus 177x minus 90. So again, I always want to think about pulling out the GCF, but I'm just going to give you an additional tip. If your leading coefficient, like in this case, it's negative 27, if it's a negative number, I always pull out a negative. Even if there's nothing else I can pull out, I just pull out a negative 1 so that the leading coefficient is positive. It just saves you a lot of trouble. So what I'm going to do here, this guy, 27, I know is divisible by 3, and I know 90 is. If you look at 177, that's not a number we work with often, but remember your divisibility rules. You sum the digits, so 1 plus 7 is 8, 8 plus 7 is 15. If that number, which in this case is 15, is divisible by 3, then the original number is as well. 15 divided by 3 is 5, so 177 will be divisible by 3. Okay, so I know I can pull a 3 out, so let me pull out actually a negative 3. And inside, everything's going to be positive. I would have 9x squared plus, this would actually be 59x, and then plus 30. Okay, so what I'm trying to factor on the inside here, now it has a GCF of 1. So keep that in mind. That's going to speed up the process. And everything is positive. So I'm going to be doing addition when I work with these integers. So let me set this up as negative 3 times. You're going to have more than one possibility because 9 is not a prime number. So you could do 3x and 3x, and then you could also do 9x, and you could do x like this. So let's think about the factors of positive 30. Let me scroll down, and you can come back up in a minute if you wanted to. So 30 is 1 and 30. You could do 2 and 15. You could do 3 and 10, and then you could do 5 and 6. Okay, so a lot of things to check. But again, because of the fact that this guy right here, this inside, the 9x squared plus 59x plus 30, which we're actually trying to factor into these two binomials here, that does not have a common factor of 3. Well, if you think about it, you can't put 1 and 30 in here because no matter how you put it in, you'd have a common factor of 3. So you can get rid of that from there. You could not put it here like this because this would have a common factor of 3. So you could check a 1 and a 30 here, but again, you're summing things. 9 times 30 is 270, and if you add that to 1, that's 271. That's way too big. So you can get rid of this one right away. Now next you have 2 and 15. Again, you can't put a 15 here or here because you're going to have a common factor of 3. So you can get rid of that from there. The 15 can't go here, but it could go here. So you could have this scenario. The outside here, 9 times 15 is going to be 135. If you add that to 2, it's 137, so it's too big. So you get rid of that right away. The 3 and 10, again, you can't put that in here. The 3 can't go here or here because you'd have a common factor of 3. So then you could do a 3 here and a 10 here. Again, you couldn't put the 3 there because you'd have a common factor of 3. So if we look at this, 9 times 3 is 27. And then you'd have 10. 27 plus 10 is going to be 37, so that's not 59. You can get rid of that. So the last possibility is 5 and 6. Now, I can't put a 6 here or here, so this is out, right? You can get rid of this altogether. It's not possible. Let me actually slide all this up so I can fit everything on the screen. And let me slide back up so we can see what we were originally factoring. So let me get rid of this. We're down to 5 and 6. Now, can I put a 6 here? No, because you'd have a common factor of 3. So it has to be a 6 here and a 5 here, and everything would have to be plus. Does this work out? The outer here would be 9 times 6 is 54, so 54x. The inner here would be 5 times x, or 5x. 54x plus 5x is 59x. So yes, this is our correct factorization. We have negative 3 times the quantity 9x plus 5 times the quantity x plus 6. All right, let's look at problem number 8. So we have 40x squared minus 108x minus 324. So eyeballing this guy, I know everything's an even number, so at least I can pull out a 2. But you know from 40, it's 4 times 10, right? I know it's 2 times 2 times 2, or 8 times 5, but let's just think about it as 4 times 10. The final two digits is an 8, so that tells me this guy is divisible by 4. And the final two digits here is 24. That tells me this number is divisible by 4. So it looks like I'm going to be able to pull out a 4 here. And so inside the parentheses, I would have 10x squared. 108 divided by 4 is going to be 27, so minus 27x. And then minus 324 divided by 4 is going to be 81. All right, so let's think about this. We have 4, and then let's split this up. And with 10, again, it's not a prime number, so you have multiple possibilities. You have 10x here and x here, and then you have 4, you'll have 5x here, and then you'll have 2x here. Okay, so we have to check all this. Let's scroll down. We'll come back up once we start eliminating things. This is negative, so I'm going to be doing subtraction. And 81 is 1 times 81. You could also have 3 and 27, and then you could have 9 and 9. Now, I'm going to be subtracting. If I put an 81 here, that's obviously way too big. And if I put an 81 here, it's still too big. So you can get rid of this because it's not going to work. Whether you put it here, 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 or here, obviously it's just going to be too big. I'm looking for, forget about the fact that it's negative, I'm looking for 27 in the end. This just will not work. You can quickly get rid of that. So next I would go to 3 and 27. Can I make that work? Well, if I put a 27 here, it's obviously way too big. And if I put a 27 here and a 3 here, well, let's try that. So we have a 3 here and a 27 here. This would be 30, and this would be 27. If you subtract those, you're going to get 3. So that's not possible here. If we try it here, if I put a 27 here and a 3 here, that's just too big. And if I put a 3 here and a 27 here, let's try that real quick. This would be 15, and then this would be 54. If you subtract 54 minus 15, you get 39. So that doesn't work either. So let's get rid of this and this. All right, so my last possibility is 9 and 9. So if I put a 9 here and here, obviously that doesn't work. This is too big, right? This is 90 minus 9, that's 81. You can get rid of this. This isn't possible. So the last choice is to put a 9 here and a 9 here. So 5 times 9 would be 45. And then 9 times 2 is 18. So if I subtract away 18, what do I get? Well, I do get 27. But I want a negative 27, so I've got to change the signs here. I want the 45 to be negative, so that means I want this negative, and I want the 18 to be positive. So in other words, I want minus and then plus, so I get a negative. So I want this to be plus. Let me erase this, and let me drag this up. Move this up here, and let me go back up so we can see everything. So checking this, the outer here is negative 45x, and the inner here is 18x. Again, if you find the sum, you get your negative 27x that you're looking for. So my answer here is going to be 4 times the quantity 5x plus 9 times the quantity 2x minus 9. All right, let's look at problem number 9. So we have 45x squared minus 260xy minus 60y squared. All right. If you have a second variable involved, like this y squared here and this y here, you just need to put it in the last position of each binomial and then forget it exists. Okay, that's all you have to do. No more difficult. In this particular case, again, this ends in a 5, this is a 0, this is a 0. So I know I can pull out a 5, and what would that give me? 9x squared, and then minus, this would be 52xy, and then minus, this would be 12y squared. So when I set this up, I know that 9 is 3 times 3 or 9 times 1, but basically I'll do 5 times, I'll go 9x, and then I'll go x. Let me make this longer. And then I'll go x. And again, you're just going to add the y into the end, because y times y would give you the y squared. And when you do your outer and inner, you're going to end up having xy involved. Okay. Then the other scenario, I'll put 5, I'll put 3x, and then I'll put 3x. And then again, I'm going to put a y here and a y here. So this guy is negative. And then again, the GCF of what's inside here is 1. Okay, so if you get any common factors when you're doing this, you can go ahead and eliminate those possibilities. So for 12, it's 1 and 12, it's 2 and 6, it's 3 and 4. Okay, let's start with 1 and 12. Can I do 1 and 12 here? No, because you'd have a common factor of 3. So you can get rid of that from this one. Can I do 1 and 12 here? Well, I could technically put a 12 here and a 1 here, but it's going to be way too big, right? You don't even need to do the multiplication. That's not going to work. So let's get rid of this and get rid of this. So now you have 2 and 6. Can I put a 6 here or here? No, you'd have a common factor of 3. I can put a 2 here and a 6 here, but I can't reverse it. The outer here would be 54, and the inner would be 2. 54 minus 2 is 52. You just have to work out the signs. Get rid of this. This is not going to work. And what we want here, let me scroll up, is to have the larger in terms of absolute value be negative, because I want this to be negative. So I'd want to put a minus here, and I want this one to be plus. This would give me a negative 54xy. This would give me a positive 2xy. So you combine like terms, you get that negative 52xy. So that's what we're looking for. Okay, so get rid of that and that. So basically you have 5 times the quantity 9x plus 2y times the quantity x minus 6y. Okay, let's look at problem number 10, our final problem for this practice test. We have 12x squared minus 57xy minus 189y squared. All right, let me put equals here. And essentially, can I pull anything out? Well, 12 is divisible by 3. Forget about 2 because this is an odd number and this is an odd number. So maybe I can pull out a 3. 5 plus 7 is 12, so yes. 1 plus 8 is 9. 9 plus 9 is 18, so yes. So I can pull out a 3 here. This would be 4x squared minus 19xy, and then minus, this is going to be 63y squared. Okay, so let me scroll down and get a little bit of room going here. Again, when we look inside the parentheses, the GCF of that trinomial we're factoring is 1. So that means that if we get anything that's common when we're forming these binomials, you can get rid of it. So let me go ahead and put 3 out in front. I'm going to put 4x, and I'm going to put y, and then I'm going to put x, and I'm going to put y. 4 can be 1 times 4, or it could be 2 times 2. So 2x, y, and you'll put 2x, and then y. All right, this is negative here, so I'm going to be subtracting with these integers. And basically, you think about 63. Well, I have 1 and 63, and then you have, it's an odd number, so it's not divisible by 2. 6 plus 3 is 9, so it's divisible by 3. It will be 3 and 21. Forget about 4, 5, or 6. You would have 7, and you would have 9. The square root of 63 is 7.9, so we can stop checking there. Okay, so would 1 and 63 work? I'm trying to get this, forget about the fact it's negative, I'm trying to get 19 through subtraction. If I put a 63 here, it's too big. If I put a 63 here, it's too big. So this does not work. A lot of times this 1 in the number you can get rid of right away. 3 and 21, does that work? Well, I don't want to put a 21 here, it would be too big. I could try a 21 here and a 3 here. The outer here would be 12, and the inner would be 21. 21 minus 12 would be 9, and I need 19, so that does not work. Let's get rid of that from there and there. So from here, I could try 3 and 21. The outer is going to be 42, and the inner is going to be 6, so that's not going to work. So you can get rid of this. Too far away. So really, we just have 7 and 9 left that we need to check. So if I put a 9 here and a 7 here, well, 4 times 9 is 36. 36 minus 7 is 29, so that doesn't work. If I reverse this and put a 9 here and a 7 here, you'd have 4 times 7, which is 28, minus 9 times 1, which is 9. 28 minus 9 would give you 19. So get rid of all this. We found what we need. We just need to make the signs work. Let's come back up. And essentially what I want, because this is negative, I want the larger to be negative. So basically this times this, I want this to be minus, and I want this to be plus. Right, so this times this, so 4x times negative 7y would be negative 28xy. 9y times x would be plus 9xy. You combine like terms there, you get your negative 19xy. Okay, so let's get rid of this. We'll just read our answer here. We have 3 times the quantity 4x plus 9y times the quantity x minus 7y. All right, let's take a look at our practice test. We're told to factor each, and for this practice test, we're going to be using our special factoring formulas. So let's look at the first problem. We have x squared minus 10x plus 25. So I want you to remember, if you have something like x minus y, quantity squared, this is x squared minus 2xy, and then plus y squared. And of course, we'll use this one later on. If you have x plus y quantity squared, this is x squared. You'll have a plus here instead of a minus. And then you'll have the 2xy and then plus y squared. So 2 easy formulas to remember. You can go from this to this or from this to this. Okay, so it works both ways. Now looking at this guy right here, if you're asked to factor a trinomial, and basically it's in standard form, if the leftmost guy is a perfect square, x being squared here, so let me write this in parentheses to make that clear. X is being squared, then minus, I'm going to talk about this middle term in a second. Let me go plus. The last guy is a perfect square, so this is 5 squared. If you notice this, you immediately want to check this middle term. Is it 2 times the first guy that was squared times the last guy that was squared? So 2 times the first guy that was squared was x, times the last guy that was squared was 5. Does this match? Yes. 2 times 5 is 10, so you would have basically minus 10x, which is what we have right here, okay? So because this matches, you can go ahead and factor this. You can take this little guy right here. So let me go ahead and say this is going to be the first guy, which is x, that was squared, then minus the last guy here, which is 5, that was squared. So x minus 5 quantity squared is what this is going to factor into. All right, let's look at problem number 2. So we have x squared minus 4. So again, with this guy, if you think about x plus y multiplied by this x minus y, so those two quantities multiplied together. Remember, if you use FOIL here, the middle two terms drop out. You're left with x squared minus y squared. So the first guy here being squared, then minus the second guy here being squared. What we're going to be doing is going in reverse. So what we want to do is go from this form to this form. So if I notice this x is being squared here, so this is a perfect square, and then minus 4 is what? It's 2 times 2, or 2 being squared. So using this formula here, all I need to do is take, well, what's in the first position here being squared? Well, that's x. So I'm going to write this out in the first position of each binomial. Then I'm going to put a plus and a minus. And then again, what's in the second position that's being squared? In this case, it's 2. So I'm going to write that in the second position of each. So this is going to factor into the quantity x plus 2 times the quantity x minus 2. All right, let's look at problem number 3. So we have 128x squared plus 320x plus 200. Again, whenever you start a factoring problem, you always want to pull out the GCF before you try to do anything. If you notice, all the numbers here are even, so that means I can definitely pull out a 2. You look at this, this is 28, 20, and then 0. So I know I can pull out a 4, but also I could pull out an 8, right? You know 200 is 8 times 25, 320 is 8 times 40, and 128 is 16 times 8. So let's pull out an 8 there. This would be 16x squared plus 40x, and then plus, this is going to be 25. So now you're thinking about your formula, right? Remember, if you have x plus y, quantity squared, this is x squared plus 2xy plus y squared. So if I look at this guy, let me go ahead and write this a little bit differently. I'm going to put my 8 here. 16 is what? It's a perfect square. It's 4 squared. So let me write this as 4x being squared, then plus, do I have 2 times x times y? Well, let me write this over here. 25 we know is 5 squared. So do I have 2 times 4x and then times 5? Let me move this down just a little bit so it fits. So times 5. 2 times 4 is 8. 8 times 5 is 40. So yeah, we're good to go. So we can just match this pattern up. And let me just put this like this. And let me slide this down a little bit so everything fits. Well, basically, let me put the 8 out here. And I want, for this x here, I'm going to want my 4x. And then plus, for my y here, I'm going to want my 5. So this is going to be 8 times the quantity 4x plus 5 being squared. All right, let's look at problem number 4. We have 24x squared minus 486. So again, these are both even numbers, so I'm going to try to first pull out a 2. But I noticed that each of these is also divisible by 3, so that means they're divisible by 6. So I could pull out a 6, and I would have 4x squared minus 486 divided by 6 would be 81. Now, if you look inside, this is a perfect square. It's 2x being squared. This is a perfect square. It's 9 being squared. So remember, you can just factor this. Let me keep the 6 out in front. You'll have the 2x plus the 9, this quantity, times the 2x minus the 9. If you want to make this crystal clear, you could write 6 times the quantity. You could do 2x like this being squared, and then minus 9 like this being squared, so that it's crystal clear when you set this up, you want the 2x right here in the first position of each. Then you have plus and minus. You have alternating signs. And then you have this 9, the last guy that's being squared, it's in the last position of each. Again, it's just a matter of memorizing the formulas and being able to apply them. Okay, let's look at problem number 5. We have 1,440x squared a minus 1,690a. So everything ends in a 0. So I know I can pull out a 10. Also, I can pull out an a. So if I pull out a 10a, I'm going to have 144x squared, then minus 169. Now, this one might not be that obvious if you're not that used to working with perfect squares. Let me make that 9 a little bit cleaner. But 144 is 12 squared. So let me write 10a times the quantity. I'm going to write 12x being squared like this. And then minus 169 is actually 13 being squared. So again, it's crystal clear what we need to do. Let's put the 10a out in front. This guy right here, this 12x is going to go in the first position of each, okay? I'm going to alternate my signs, so plus and minus. This last guy, this 13 being squared, is going to go in the last position of each. So we get, let me make that 3 better, we get 10a times the quantity 12x plus 13 times the quantity 12x minus 13. All right, let's look at problem number 6. So we have 432x squared plus 504x plus 147. Let's scroll down a little bit. So I'm thinking about, since these are all pluses, again, the x plus y, quantity squared, the x squared plus 2xy plus y squared. So is there anything I can pull out? Well, everything is not even. This is an odd number here, this 147. But it does look like 1 plus 4 is 5, 5 plus 7 is 12, 5 plus 0 plus 4 is 9, 4 plus 3 is 7, plus 2 is 9. So I can pull out a 3. Let's start with that. 432 divided by 3 is 144. We know that's a perfect square. Then x squared, then plus 504 divided by 3 is 168. So then times x, and then plus 147 divided by 3 is 49. Let me close that down. I think we know the formula. You can write it down. You can pause the video if you need to. But I think most of you know this formula. Let me put equals here. And essentially, what I want to check is to make sure, let me do this as 12x being squared. Let me put this over here as 7 being squared. We know 49 is 7 squared. Is this middle term 2 times the first guy, which is 12x, times the last guy, which is 7. 2 times 7 is 14. 14 times 12 is 168. So what you can do is you can say that the 3 is out in front, and then basically you're going to have this first guy, so 12x, then plus this last guy here, the 7. So 3 times the quantity 12x plus 7 being squared. All right, let's take a look at problem number 7 now. So we have 8x cubed minus 27. So this problem and the next problem, we'll see the difference of cubes here, and then in the next problem, we'll see the sum of cubes. But the formula for this is quite simple to remember. So I always remember same, different, plus, or positive if you want to think about it that way. So same, different, positive. So if you had something like, let's use a and b. Let's say we had like a cubed, and that kind of looks like a 9, so let me make that more clear. So a cubed plus b cubed. This is going to factor into, first you have a and you have b. And like I said, same. So that means the sign is going to be the same. So this is plus, so this becomes plus. Then over here, you're going to have a squared, you're going to have ab, and you're going to have b squared. So the next sign is going to be different. Because this is plus, this becomes minus, and then this one is always plus. So same, different, plus. Or you could say same, different, positive, or however you want to remember it. But basically, the first sign is always the same. If this is plus, this is plus. The second sign is always different. If this is plus, this is minus. And the last sign is always a plus. So if you did, let me change colors here. If you did a cubed minus b cubed, again, you're still going to have the same terms there. It's just that the signs are going to be different for everywhere but this last guy. This guy is always going to be a plus. Okay, so you don't have to worry about that one. Again, same. So the first one's going to be minus. Different. The second one's going to be plus. Again, this one's always plus. Okay, so using this second formula here, and let's actually get rid of this one so we can fit it all on the screen. And I'm actually just going to drag this up just a little bit right there. Let me scroll down so it all fits. Okay, so I'm going to rewrite this. Let me put this off to the side. I'm going to rewrite this as 2x being cubed like this, so this is clear. And then minus 27, I'll write 3 cubed there to make that clear. So what do we have here? Our a, or our first guy being cubed, is the 2x. So both the 2 and the x. So let me write this down here. I'm going to put a 2x here. And then I'm going to put a 2x being squared here. And then let me put a 2x here. And then that's it. So then the next guy is the 3. That's the last guy that's being cubed. That's the b here. So where is that going to go? It's going to go right here. And then it's going to go right here. And then it's going to be squared at the end. So it's going to go right there. Let me go ahead and close that down. Let me maybe make that a little bit better. Okay, so the signs. Remember, first sign is the same. Second sign is different. Last sign is always positive. That's how I always remember this. Again, these formulas, when they start getting bigger and bigger, get harder to remember. So I remember same, different, always positive. Same, different, always positive. The terms are pretty easy to remember overall. Okay, so from here, let me just erase this. From here, I can just simplify. Let me put equals. Let's scroll down a little bit. So from the first part here, I don't really have to do anything. I'm just going to leave this quantity 2x minus 3. In the second part, what can I do? Well, 2 squared is going to be 4. X being squared is just x squared. Then plus 2 times 3 is 6. Then times x, so this is 6x. And then plus 3 squared is 9. So this 8x cubed minus 27 is going to factor into the quantity 2x minus 3 times the quantity 4x squared plus 6x plus 9. All right, let's take a look at problem number 8. So we have 128x cubed plus 2y cubed. So if I look at 2 and I look at 128, those are obviously not perfect cubes. But remember, the first thing is always to pull out the GCF if it's not 1. In this case, this is a 2 and this is 128. They're both even numbers, so I know I can pull out a 2. So let's start with that. I pull out a 2 and I'm going to get 64, which is a perfect cube, x cubed, plus you're going to have y cubed. Okay, well, I can rewrite this. Let me keep the 2 out in front. 64 is what? It's 4 times 4 times 4, or it's 4 cubed. So I'm going to write 4x, and then I'm going to cube this, and then plus, let's go ahead and put parentheses around the y to make this crystal clear, and I'm going to cube this. Okay, so what is this going to be? Can we do this without our formula? I think we can. So again, when you lay this out, let me put the 2 out in front. You can have a set of parentheses there and a set of parentheses there. Let me actually move this a little bit longer. So remember, the first guy is going to go here. It's going to be squared here. And then it's going to be involved in a multiplication here. So let me put times there. The second guy is going to go right there. It's going to be squared here. Let me wrap it in parentheses to make it crystal clear. And it's going to be multiplied there. Again, do you remember your signs? Remember, and I messed that up, so let me drag this back up. Remember, for the signs, it's same, different, always positive. This is a plus, so it's same, different, always positive. So let me put equals. I think we can fit this. So we'll have 2 times the quantity. This is 4x plus y. Don't need to do anything with that. Then times this quantity, 4 being squared is 16. Then you'd have x squared. Then minus your 4xy. Then plus your y that's going to be squared. So this 128x cubed plus 2y cubed is going to factor into this 2 times the quantity 4x plus y times the quantity 16x squared minus 4xy plus y squared. All right, let's look at the last two. These are a bit tricky. So for problem number 9, you see you have x squared minus 6x plus 9 minus y to the 4th power. So when you first saw this, you're probably thinking, well, this doesn't match any formula that we have. Everything is either a binomial or a trinomial. But what you're meant to do is notice that this guy right here is a perfect square trinomial, meaning we can factor it into a binomial squared. If you have x squared minus, I'm just going to write this as 2 times 3 times x, then plus 3 being squared, notice that this is 2 times the first guy, which would be x. Let me make this more clear. The first guy, which is x being squared, times the last guy, which is 3 being squared. So this factors into the first guy minus the last guy quantity squared. So x minus 3 quantity squared. So that's the first thing you would want to do here. I'm going to write this as x minus 3 quantity squared, then minus y to the 4th power. So maybe you did this and you got stuck. Well, you can write y to the 4th power using the rules of exponents as y squared being squared. So do you see what we're doing now? We have the difference of squares. If you have a squared minus b squared, this is the quantity a plus b times the quantity a minus b. So we're just going to match things up and we're going to plug in. That's all you need to do. So in this case, a is the quantity x minus 3. Okay, so I'm just going to write the quantity x minus 3, and then let me put a plus sign here. Let me close that down, and then again, I'm going to write x minus 3. I'm going to put a minus sign here, and I'm going to close that down. What is b? It's y squared. So I'm just going to put a y squared there and a y squared there. That's all you have to do. That's how you achieve the factoring here. So we get the quantity x minus 3 plus y squared times the quantity x minus 3 minus y squared. All right, let's look at the last problem, problem number 10. Again, this one is a bit tricky. So let's go through it step by step. So we have y squared minus x squared plus 6x minus 9. So you might have looked at x squared plus 6x minus 9 and said, well, that doesn't exactly match something that I'm used to factoring. If you had x squared minus 6x plus 9, this is what? This is the quantity x minus 3 squared. But I don't have that, but I could create it. Notice that this is a minus, this is a plus, and this is a minus. So all the signs are exactly opposite from what you would need. So first I'm going to write y squared there. And then I'm going to write a negative, and I'm actually going to wrap this polynomial in parentheses. What does that mean? It means I'm factoring out a negative 1. Okay, if you're more comfortable, you could put plus negative 1 there, but it's really not necessary. So instead of minus x squared, this would just be x squared. Again, if this gets distributed, you're back to your negative x squared. And then instead of plus 6x, this is minus 6x. Instead of minus 9, this is plus 9. And we know now that this is x minus 3 quantity squared. So I can actually make a replacement there and say this is y squared minus this x minus 3 quantity squared. Okay, so now we see something that we just talked about. If I have a squared minus b squared, this is a plus b, this quantity, multiplied by the quantity a, and I put a plus there, it should be a minus, so a minus b there. All right, so actually let me erase this. I'm just going to box this off so we can set this up. So what's going to go in the first position of each is whatever is being squared. In this case, y is being squared. You can wrap this in parentheses to make that clear. The y is being squared, so that goes here and that goes here, right? From here and here. So all we're doing is matching the formula. Then you're going to have a plus, and then you're going to have a minus. So what is b here? It is the quantity x minus 3 that is being squared. And I'm going to wrap this in parentheses. I'll drop them in a second. So you want that quantity x minus 3. And then here you want this quantity x minus 3. The reason I'm putting this in parentheses is because there's a minus sign out in front here. So that's important because you do need to change some signs. So actually, let me get rid of all of this. So obviously I have a plus in front of these parentheses. I can just drop that and I'm done. But here I have a minus in front of this quantity here. So I need to distribute that or change the sign of each term before I drop the parentheses. So I would have a negative x and then a positive 3. Okay, so let me close this down a little bit better. So what I end up with here is the quantity y plus x minus 3 times the quantity y minus x plus 3. All right, let's take a look at our practice test. So we're told to factor each. And for the first problem, we're going to look at x to the 4th power minus 4. So whenever I see a binomial or a two-term polynomial and I have subtraction involved, I'm thinking about, do I have the difference of squares or do I have the difference of cubes? In this particular case, I see that 4 here is 2 squared. Most people know that it's a perfect square. So I would start by writing, this is going to possibly be something squared minus, in this case, this would be 2 squared. So can I transform this x to the 4th power into something being squared? Yes. Remember, your power to power rule tells you to keep your base the same, in this case it's x, and multiply exponents. So I know there would be an x here because the base stays the same. Well, what do I need to multiply by 2 to get to 4? Well, all I would have to do is a simple division. 4 divided by 2 is 2. So I can just put a 2 here, and I'm basically good to go. X squared squared, x stays the same, multiply exponents, 2 times 2 is 4. So now I have the difference of squares, and I can use my formula immediately, or if it makes you feel more comfortable, you can use a substitution. Okay, this is really up to you. So let's do it both ways. So the first way, I would take the first guy that's being squared, the x squared is being squared, and I'm going to put that in the first position of each binomial that I set up. And then I'm going to alternate my signs. So let me put a plus here and a minus here. And then I'm going to take the last guy that's being squared, so the 2 in this case, and I'm going to put that in the last position of each binomial. When you do these problems, make sure you check to see if there's any additional factoring. Sometimes there's extra stuff you can do. For example, if this would have been a 4 here, you'd have the difference of squares again, so you'd have to keep factoring. But in this case, there's really nothing else we can do, at least using integers. So we would have the quantity x squared plus 2 times the quantity x squared minus 2. So we would stop there. Now, if you wanted to solve this using the substitution technique that we talked about in the lesson, you could do something like let u be equal to x squared, and then you could plug in a u there. So essentially you would be factoring u squared, and then minus this 2 being squared, like this, and this just ends up being u plus 2, this quantity, times the quantity u minus 2, and then once you're done, you have to substitute again, so you're going to put an x squared in here and here, okay, and you're right back to this answer of the quantity x squared plus 2 times the quantity x squared minus 2. Let's look at the second problem. So we have 6x to the power of 2/3 minus 7x to the power of 1/3 minus 3. So typically, when you're working in a factoring section, you get stuff that looks like this. So maybe you would see something like 6x squared minus 7x and then minus 3. This is what we call a quadratic, right? And basically, this guy is a 2 and this guy is a 1, and here you don't have a variable. So if you see something with some weird exponents, like 2/3 and 1/3, you want to check to see if this is what we call quadratic in form. So in other words, is this highest exponent right here double that of this smaller exponent here? Here, this is 1 and this is 2. So if I multiply 1 by 2, I get 2. Here, this is 2/3 and this is 1/3. If I multiply 1/3 by 2, I do get 2/3. So if you see that pattern, you can make a little substitution. So let me go ahead and put let. I'm going to say u is going to be equal to, you always want to use x raised to that smaller power. So x raised to the power of 1/3. And then we're just going to make a simple little substitution. Let me move this down here. To make this crystal clear, I'm going to write this as 6x, and let me wrap this inside of here. This is going to be squared. So how do I get what goes in here? Well, again, 1/3 times 2 would give me the 2/3. So I can just put a 1/3 in right there like that. And again, x stays the same. 1/3 times 2 is 2/3, so I'm right back to what I had. Then minus 7x to the power of 1/3, and then minus 3. So this is basically your setup. You're always going to take this guy right here and put it in the parentheses right there, and it'll be raised to the second power when this guy is quadratic in form, okay? So everywhere you see x to the power of 1/3, you replace it with u. That's all you have to do. So what I'm going to do is say that I have 6u squared minus 7u, and then minus 3. So we're going to factor this guy, which we're more comfortable with. So how do we factor this? Again, you can use factoring by grouping. You can use reverse FOIL, whatever you want to do. Since this is a 3 here, I know it's negative, but since this is a 3 and that's a prime number, I think we're probably better off using reverse FOIL. So let's go ahead and set up some parentheses here. 6 is not a prime number, so this would be 6u and u. And then you could also have 3u, and then you could have 2u. So 6 is 1 times 6 or 3 times 2. Now, one thing that's going to save you some time, again, 3 is a prime number, so it's 1 and 3. You can't put a 3 here, and you can't put a 3 here, right? Because there's no common factor of 3 in this trinomial. It's not possible to have a common factor of 3 here or here. So you can get rid of that. You only need to check a 3 here and a 1 here, or a 3 here and a 1 here. Now, because this is a minus, I want to do subtraction. So my outer here, 6 times 3 is 18. Forget about it. It's too big. You can get rid of this. Not possible. Then this guy right here, 3 times 3 is 9, and 2 times 1 is 2. 9 minus 2 is 7. So I know I need negative 7, so this is what I want. I just need to play with the signs. So the larger in terms of absolute value is going to need to be negative. So this right there, this would be negative 9u. This should be positive, so this would be plus 2u. Combine like terms, you get that minus 7u. So this is the factorization we're looking for, but again, we're not done. A lot of people stop at this point and they turn in their test, and you're going to get at least points taken off. So remember, u is x to the power of 1/3. So all you have to do, I'm going to put equals here. I'm going to get rid of u, and everywhere I saw it, I'm just going to put x to the power of 1/3. Let me scooch this down so it's a little bit cleaner. And here I'll put x to the power of 1/3. And again, let me scooch this down so it's a little bit cleaner. So we can say, let me get this out of the way, and let me scooch this answer up. And basically what we have here is the quantity 3x to the power of 1/3 plus 1 times the quantity 2x to the power of 1/3 minus 3. Okay, let's look at question number 3. So we have 3x to the 7th power plus 31x to the 5th power plus 56x cubed. Scroll down a little bit. So you'll notice that 3 is a prime number and so is 31. So number-wise, I can't get anything out. But variable-wise, I have an x, an x, and an x. The smallest exponent is a 3. So I know I could pull out an x cubed here. This would give me 3x to the 4th power plus 31x squared, then plus 56. Okay. So you could factor this, again, without using a substitution, but some students find it a little bit easier. So this guy right here, again, is quadratic in form. This exponent is double that of this exponent. But I'm going to write this, I'm going to put x cubed here, as 3. Again, all I'm going to do is, I'm going to end up squaring this, and what's going to go inside is always x raised to that smaller power. So this is x squared here, because again, it's double, so x squared squared, I'm multiplying 2 times 2 to get to 4. Then plus, I'll have 31x squared, then plus 56. And everywhere I see x squared, I'm just going to plug in a u. Let me scroll down and get some room going here. You can write this out, so let u be equal to x squared. So everywhere I see x squared, so here and here, just going to plug in a u. You can wrap this in parentheses if it's more comfortable for you. It's really up to you. I'm going to say this is x cubed times the quantity. You'll have 3u squared plus 31u, and then plus 56. Okay, let's scroll down. We'll come back up in a minute. So how do I factor this guy right here? Let me go ahead and change colors real quick. Again, you can use factoring by grouping, or what we call the AC method, or you could go ahead and just use reverse FOIL. This guy is prime, so let's use reverse FOIL. I'm going to go 3u and u. Now 56 does have some factors, so we're going to have to check a lot of stuff. So you have 1 and 56. Everything is a plus, so I know I'm going to be adding. So let's think about this. 56, would that ever work? If I put a 56 here, that's obviously not possible. It's too big. If I put a 56 here, it's still too big. So that's out. So next you have 2, and you would have 28. Would that work? Well, 28 over here would be too big. But if I put a 28 here and a 2 here, my outer would be 6 and my inner would be 28. That's too big. The next one would be what? It's not divisible by 3, but it would be divisible by 4. It's 4 and 14. So if I put a 14 here, it's obviously too big. If I put a 14 here and a 4 here, that's too small. The next guy would be 7 and 8. So if I put a 7 here and an 8 here, you would have 21 plus 8, which is 29. Let me reverse that. Let's put an 8 here and a 7 here. Now you're going to have 24 plus 7, which is 31. Okay, so this is what we want. Now again, because, let me erase this real quick. Because we let u equal x squared, all you need to do is get rid of the u and then plug in an x squared, and you've basically found your factorization. Let me make this plus sign a little bit better here. Let me get rid of all this. So we'll come back up here and just read the answer. We're going to have x cubed times the quantity 3x squared plus 7 times the quantity x squared plus 8. All right, let's take a look at problem number 4 now. So we have 72x to the 8th power plus 42x to the 4th power minus 294. All right, let's scroll down a little bit. So I know I can pull something out. Everything's even. But also, if you use your divisibility rules, 7 plus 2 is 9. 4 plus 2 is going to be 6. And then 2 plus 9 is 11, plus 4 is 15. So everything here is divisible by 3. So I know if something's divisible by 2 and 3, at minimum I can pull out a 6 here. And then we can check inside and see if anything else can come out. But I know I can pull out a 6. So 72 divided by 6 is 12. So this would be 12x to the 8th power plus, if I look at 42 divided by 6, that's 7. So 7x to the 4th power. And then minus 294 divided by 6 is 49. Okay, so should we use substitution here? I think it would be a good strategy, again, because in this particular case, this guy is double this guy, so it's in quadratic in form, as we say. You don't have to use a substitution. I'm just going to do it for completeness. So let's let u be equal to, again, x to the smaller power, so x to the fourth power. For the sake of completeness, you could rewrite this and say this is 6 times the quantity. Again, 12. I'll go ahead and wrap this and say x to the fourth power, whatever this guy is, the smaller guy, being squared, plus 7 times, you'll have this x to the fourth power here, then minus 49. Again, just doing this extra step for clarity. So now you can say this is 6 times the quantity. This will be 12u squared plus 7u minus 49. So everywhere you see x to the fourth power, here and here, just plug in a u. Okay, so now we're going to factor this, and then we can substitute again when we're done. Let's come down here, and let's go ahead and work through this. So I'm going to put equals here. I'm going to keep my 6 out in front. Now 12 has quite a few possibilities, but 49 does not. 49 is 7 squared. So I know I'm going to have a 7 in the last position of each, but 12, you could have 12 times 1. Let's start with that. So 12 times 1. Is this going to work? No, I'm doing a negative here, so I want to subtract. This is just too big. Okay, so you can get rid of 12 and 1 right away. That's not going to work. So the next one I would do is 2 and 6. Let's do 2 and 6 here. Is that going to work? The outer here would be 14, and the inner here would be 42. That's too far away, so that's not going to work. So next you'd have 3 and 4. So let's put 3 and 4. Your outer here is 21. Your inner here is 28. 28 minus 21 is 7. So I just need to get my signs right. So I want my inner here, this one to be plus. Let me make that better. And I want my outer here to be minus. So in other words, this times this would be negative 21u, and this times this would give me the positive 28u. So 28u minus 21u will give me that 7u right there. Okay, so now all I need to do is back substitute. So again, u is equal to x to the fourth power. So just take everywhere there's a u and put in x to the fourth power, and you're basically done. And so we have 6 times the quantity 3x to the fourth power plus 7 times the quantity 4x to the fourth power minus 7. All right, let's look at problem number 5. So we have 16x to the 8th power minus 28x to the 4th power minus 98. So just eyeballing this, I know that everything is even here. So at least I can pull out a 2. And then inside we would have 8x to the 8th power minus 14x to the 4th power. And then minus 98 divided by 2 is 49. So again, we notice that this 8 here is double that of the 4. So you can use your substitution technique. Of course, you don't have to. You could just set this up, and you could do this by saying that's 2 here. Let me set this up here. Basically, you know this is x to the 8th power. So this is going to come from x to the 4th power times x to the 4th power. But again, let's just use the substitution for right now. I think just for clarity. So I'm going to say let u be equal to x to the 4th power. So always the one that's smaller. And again, just make sure that this exponent here is double that of this one so that this works out. I'll change colors. I'm going to put 2 times the quantity. I'll do 8u squared minus 14u, and then minus 49. And the idea here is that u is going to be x to the 4th power, right? Something that's the smallest guy. So let u be equal to x to the 4th power. We'll back substitute in a moment. So for 8, I have 1 and 8, or 2 and 4. And for 49, I have 7 times 7. So that makes this ideal to use reverse FOIL. Let me get rid of this. And let me write another set of parentheses here. Let's go ahead and put 8u and u. Let's put 4u and 2u. Everything here is going to be a 7, so you don't have to worry about that. This is a subtraction here, or a negative, so I know I'm going to subtract. So 8 times 7 is 56, and 56 minus 7 is 49. So this is immediately out. Then for this one, you would have 4 times 7, which is 28. And you would have 7 times 2, which is 14. 28 minus 14 is 14. Again, don't worry about the sign there. We're going to fix that right now. You drag this up here. I want this guy right here to be larger in terms of absolute value. So I need this to be negative and this to be positive, right? So this would be negative 28u, and this would be positive 14u, okay? So that would give us our correct factorization. So let me get rid of all of this and this. Again, we let u be equal to x to the 4th power, so you can just put that in there. You don't really need this step here. You can pretty much figure out that x to the 4th power times x to the 4th power will give you x to the 8th power. So you can just write it in there and just work with the coefficients like you always do. It's really up to you if you want to use the substitution technique here. Let's get rid of this. Let's just say our answer is 2 times the quantity 4x to the 4th power plus 7 times the quantity 2x to the 4th power minus 7. All right, let's look at problem number 6. So we're going to have 16x to the 8th power minus 108x to the 4th power plus 162. So it looks like I can only pull out a 2. So let's go ahead and say this is 8x to the 8th power minus 108 divided by 2 is 54. So then x to the 4th power, and then plus 162 divided by 2 is 81. Again, you can make a substitution, or you can realize that basically it's going to be x to the 4th power times x to the 4th power. That's going to give you this x to the 8th power. It's really up to you. So we could say let u be equal to x to the 4th power. So again, this guy, this x being raised to the 4th power, and this guy, this 8 is double that of the 4, right? So we know we could write this off to the side. Let me do this in black. So 2 times the quantity. We're going to go 8. This will be u squared minus 54 u, and then plus 81. And again, all I'm doing is I'm plugging in a u everywhere there's x to the 4th power. This x to the 8th power could be written as x to the 4th power being squared. Let me get rid of that highlighting there. And let's just try to factor this. So 8 is really not that bad. It's either 1 times 8 or 2 times 4. So let's go ahead and put some parentheses here. I think we can get this pretty quickly using reverse FOIL. So we're going to have 8u and u, and then we're going to have 4u and 2u. Now this is positive and this is negative, so I know my signs are going to be negative, right? Negative times negative is positive, negative plus negative is negative. So let's think about 81. You've got 1 and 81, you've got 3 and 27, and you've got 9 and 9. You could use 3 and 27, but again, because you're adding, if you put a 27 here, it's way too big. And if you put a 27 here and a 3 there, let's try that real quick. Maybe that would work. This would be 24 plus 27, and that would be 51. Again, I'm working with absolute value. I'm ignoring all the signs. So that's too small, so that does not work. Let's get rid of this and this. And then let's try, if I put 27 here, it's too big. If I put 27 here and 3 here, it's going to be 27 times 2 is already 54. So again, in terms of absolute value, I'm not worried about the sign. It's already too big, so forget about that. That's not going to work. So let's work with 9 and 9. Let's put a 9 here and a 9 here. Well, that's too big. You can get rid of this as a possibility. It's not going to work. So you'd have to check 9 and 9 here. So 4 times 9 is 36. And then 9 times 2 is 18. 36 plus 18 is 54. Again, I'm just working with the absolute values. So it looks like this is exactly what I want. If I consider the fact that these are negatives, you have this 4u times negative 9. This is negative 36u. And then you have this negative 9 times 2u. That's minus 18u. Negative 18u plus negative 36u will give you that negative 54u. Let's get rid of that, and let's get rid of that. Let's move this up here. Everywhere there's a u, I'm just going to write x to the 4th power, and then x to the 4th power. Let's get rid of this and get rid of this. Now, most of you might stop here and report your answer as 2 times the quantity 4x to the 4th power minus 9 times the quantity 2x to the 4th power minus 9. But remember, in the first problem, I told you always have to check for additional factoring. If you get a binomial and something is squared in the end, 2 is not a perfect square, but over here 4 is. This guy, this 4x to the 4th power, I could really write this as 2 times the quantity. Let's go ahead and say this is 2x squared being squared minus, I'll put 3 being squared. So I have the difference of squares here, so I have to keep factoring. You always want to factor completely. So let me go ahead and scroll down a little bit here. So this is going to end up being 2 times the quantity. This 2x squared would be in the first position of each binomial. You close that down. Let me put this 2x to the 4th power minus 9 like this. And then I have a plus and a minus. And then this last guy being squared is going to go here and here. So always make sure you check for additional factoring when you do these problems. Sometimes there's some extra stuff you have to do. And if you put this as your answer on your test, your teacher will rightfully probably take off quite a few points just because you didn't completely factor. You factored, but you didn't get it all the way there. So your answer here is 2 times the quantity 2x squared plus 3 times the quantity 2x squared minus 3, then times the quantity 2x to the 4th power minus 9. All right, let's look at problem number 7. We have 18x to the 6th power minus 24x cubed plus 8. So let me scroll down here and see what we got. I know I can pull out at least a 2. And inside I would have 9x to the 6th power minus 12x cubed and then plus 4. Now, again, when you work with the trinomial, if you see something squared, and then you have plus, minus, plus, you're thinking, is this a perfect square trinomial? So first off, let's use our little substitution because this is quadratic in form. This 6 is double that of the 3. So I'm just going to write this as 2 and then times the quantity. I'll go 9, and then I'm going to put this as u squared. And then minus, we're going to go 12u and then plus 4. And what I'm doing here is I'm letting u be equal to, again, x cubed, because that's the smaller guy, right? So x raised to the smaller power. So from here, again, you can check your little formula. And you could say, can I write this as 2 times the first guy, so 3u being squared, then minus 2 times the first guy, which is 3u, times the last guy, really 4 would be 2 squared. So let me put 2 here, and then plus this 2 being squared. Does that match up? 2 times 3 is 6, 6 times 2 is 12. So yes, this does match up. And so I can factor this into 2 times the quantity. You would have the first guy, which is 3u, so that first guy being squared. The minus comes along, and then I would have this last guy that's squared right here, that's that 2, and then this quantity is squared. So again, because we let u be equal to x cubed, let me erase everything. You can really just get rid of this and put equals, and then I'm just going to get rid of this highlighting and get rid of this u and put x cubed in here. So we get 2 times the quantity 3x cubed minus 2 squared. All right, let's take a look at problem number 8 now. So we have 48x to the 8th power minus 4x to the 4th power minus 140. So what do we want to do here? Let me see what we can pull out. I know we can pull out a 2 because everything's even, but this is a 4. This ends in 40, and this is 48. So everything is actually also divisible by 4. So let's pull that out. That would give me 12x to the 8th power, then minus x to the 4th power, then minus, this would be 35. Okay. So again, same song and dance. This is quadratic in form. So I'm just going to let u be equal to this x to the 4th power. That's all we really need to do. So you could write this as 4 times the quantity 12u squared minus, this is just going to be u, and then minus 35. Okay, so if I'm trying to factor this, let me scroll down a little bit, just get this on the screen. Put the 4 out in front. Now, do I want to use reverse FOIL here? I think we do. 35 is only 1 times 35 or 5 times 7. It's unlikely that 1 times 35 would even work. So we just work with 5 and 7. So you would have 12u and u. And because this is a negative here, I want to use subtraction when I work with these integers. And I'm trying to get something that's basically, in terms of absolute value, positive 1. So do I even want to think about 12 and 1 here? No, that's just too far off. So let's go with 2 and 6 to start. That might work. So 2 and 6, and I'm only going to play with 5 and 7. So if I put a 7 here and a 5 here, that would be 30 and 14, too far away. If I flipped it around and put a 7 here and a 5 here, this is 10 and 42. That's too far away, so that's not going to work. So get rid of 2 and 6. Let me put my u back in there. So what's next? You would have 3 and 4. So let me put a 3 here and a 4 here. So again, I'm working with 5 and 7. So if I put a 7 here and a 5 here, this is 15, and this is 28. That's too far away. If I put a 7 here and a 5 here, this is 21, and this is 20. So that would work. You've got to play with the signs. I want this guy to be negative, right? So negative 21u. I want this guy to be positive, so positive 20u, right? So negative 21u plus 20u will give me that negative u. Okay, so this is what I'm looking for. And again, all I want to do, let me erase everything. Put this like this. I'll put equals. And again, u is equal to x to the 4th power, so get rid of this and this. We'll just put x to the 4th power here and here. We'll just say our answer is 4 times the quantity 3x to the 4th power plus 5 times the quantity 4x to the 4th power minus 7. All right, let's look at problem number 9. So a slightly different format. We have 10 times the quantity 2x minus 1 being squared, minus 19 times the quantity 2x minus 1, minus 15. So now we have something, again, that looks a little bit different, but I want you to notice that this and this, it's the same. So we have 2x minus 1, this quantity. Here it's squared, here it's raised to the 1st power. So again, we have something that's quadratic in form. This is double that of this, right? 2 is double that of 1. So all I have to do is make a little substitution. I'm going to factor 10u squared minus 19u, and then minus 15. And then when I'm done with this, I'm going to plug in a 2x minus 1 everywhere there's a u. That's all I have to do. And to make this crystal clear, because I know some people might be lost from this, let me actually slide this down. And I'm going to visibly write that I'm going to let u be equal to 2x minus 1. So I just substituted. Here I put a u, here I put a u. That's how I got this. So let's go ahead and factor this guy right here. And how would we do that? Well, we have a 10, and 10 is 5 times 2 or 10 times 1. Let me think about this. Let me set this up. So 10u, and then you'd have u, and then you would have 5u, and then you would have 3, or actually this would be 2. So 2u like this. Okay, so 15, you've got 1 and 15, and then you've got 5 and 3. Now again, because this guy doesn't have a common factor of 5, you really are going to limit your choices because you can't put a 15 here, and you can't put a 15 here. I could put a 15 here and a 1 here. Remember, you're doing subtraction because this is a negative here. The outer here is just too big, right? So 10 times 15, too big. And if I put a 15 here and a 1 here, 5 times 15 is 75. That's too big as well. So you can immediately get rid of this 1 and 15. That's not possible. Then you have 5 and 3. Can't put a 5 here, but I could put it here. Could put a 3 here. Can't put a 5 here, but I could put a 3 here and a 5 here. So the first one, 10 times 5 is 50. This is too big, so this is gone. Get rid of this. Not going to happen. This one, 5 times 5 is 25. 3 times 2 is 6. Yeah, 25 minus 6 is 19. So let's go ahead and bring this up here. So I want my outer to be bigger in terms of absolute value, and I want this to be negative. So this would be negative 25u. I want this to be positive. So smaller in terms of absolute value, this would be positive 6u. So basically you'd have negative 25u plus 6u. That gives you that negative 19u. And let me put equals here. Remember, u is 2x minus 1. So here, this is a bit tricky. Okay, let me actually write this below. Everywhere you see a u, you're putting 2x minus 1, but 5 is multiplying this entire thing. So you've got to wrap this guy in parentheses when you do this. This is a common mistake. Okay, so go ahead and go 5 times the quantity 2x minus 1, then plus 3. Again, all I did was I plugged in a 2x minus 1 for u right there, and I wrapped it in parentheses because 5 is multiplying whatever that is. Okay, then times, I'm going to have 2. Again, wrap this in parentheses for u. I'm plugging in this 2x minus 1, then minus 5. Okay, let's come down here. And let's think about this a little bit and see what we have. So I'm going to put equals here. I'm going to actually get rid of this altogether. And we'll say 5 times 2x would be 10x. And then if we do 5 times negative 1, that's negative 5. And then you have plus 3. Now, negative 5 plus 3 is negative 2. Let's put minus 2 there. And we'll have some additional factoring, but I'll do that in a second. 2 times 2x would be 4x. And then minus 2 times 1 is 2. And then you have minus 5 there. Negative 2 minus 5 would be negative 7. So let's close that down. And then basically you can pull out a common factor of 2. So I'm going to say this is 2 times the quantity. I'll probably never fit this on the same line. Let me scroll down just a little bit more. Let me change colors here. So this is 2 times the quantity. This would be 5x and then minus 1. So I'm just pulling out a 2 from here and here. And then times the quantity 4x minus 7. So 2 times the quantity 5x minus 1 times the quantity 4x minus 7. Okay, let's look at problem number 10. This will be the final problem for this practice test. So we have 3x plus 5, this quantity squared, minus 18 times the quantity 3x plus 5 plus 81. So just like the last problem, we're going to let u be equal to this 3x plus 5. Again, this exponent here is a 1, this exponent is a 2, so this guy is double that of this guy, so this is quadratic in form. So to make this clear, let u be equal to this 3x plus 5. So we're going to factor u squared minus 18u and then plus 81. Now I want you to notice, again, if you get something like 81 or 49 or 64 or 169, something that's a perfect square in the end, you want to check, is this guy a perfect square trinomial? You have a minus here and a plus here and a plus in the front, so it looks like it might work out. So could I say this is u squared minus 2 times, this would be 9 times u plus this 9 being squared. Yes, this works out. Negative 2 times 9 is negative 18 times u would be this minus 18u in the middle. And we know the ends work out. So let's go ahead and say that this is going to factor into, I'm just going to do this up here, this is going to factor into this u, first guy being squared, minus this last guy being squared, the 9, quantity squared. Okay, let's get rid of this. So now, everywhere there's a u, I'm plugging in 3x plus 5. So I would basically have this 3x plus 5 and then minus 9 quantity squared. Let's get rid of all this. We don't need it anymore. We just want to simplify. Let me put equals here. So now what I'd have is the quantity, 3x, and then 5 minus 9 is going to be negative 4. So minus 4. So this quantity being squared.